sustainable development. As you know that during this session we are going to have a talk on green buildings. For this talk, we have an expert, Mani Khanna. He is basically a mechanical engineer. He has done his post-graduation in environment and sustainable development. He is also Indian Council and accredited professional, and also he is Bureau of Energy Efficiency certified BCBC master trainer. He has got a 5 years of rich experience in the field of green building and energy efficiency based projects. He has been actively associated with youth Indian Society of Heating, Refrigeration and Air Conditioning Engineers, as well as American Society of Heating, Refrigeration and Air Conditioning Engineers, India chapter. And so he will be talking today on the green buildings. What are the aspects, what are the ratings with respect to buildings like water efficiency, energy efficiency, among other parameters which are required for green building, and it is a need of the hour. It is very much required in the future, and such type of acts they are being implemented, and it is strictly mandatory in the new and upcoming buildings. So I request Manikanaji to kindly highlight the various issues and features with regard to green buildings.
So yeah, good morning everyone. Thanks ma'am for your brief introduction, and we'll discuss today on the green buildings, why we are discussing about green buildings and why this green building is important and need of our hour. So basically the framework which we'll discuss today about is so overview of the green buildings and the green buildings and sustainability, aspects of green buildings, components, energy efficiency, design and construction, benefits, and what are the cost factors in preparing and design and construction of the green buildings, and another than the cost, what are the variations, what will be the cost parameter when we'll design and construction of green buildings, and other than we will discuss about the rating system. So various rating system we are the working in India and abroad for the rating system provide green building certifications, and another is how the green building improve businesses. So the basically major scenario is the why buildings, and why we are discussing why the buildings are major challenges, because as we know the buildings are creating day by day. So the urbanization from rural people are shifting into urban areas, and the buildings construction is growing day by day. So the different sectors including hotels, hospitals, different sectors according to commercial buildings or other than the residential areas, it's increasing day by day. So the energy consumption, demand of energy consumption is also increasing day by day. So, but in India, we have natural resources, don't have enough natural resources to conserve it, to procure it, and to provide the increasing demand of energy consumption. So that's why we need to preserve our resources, to protect our resources, and to provide the better environment to the society and save our environment. So this will be working under green buildings. So as is the current scenario, the building scenario is currently only 659 million square meter as per USAID Eco3. This is the data which is collected from, and in 2030, which will be the buildings will be constructed around 1900 million square meter. This will be the estimated, and as you can see in the year 2010, the 659 million square meter the building has been constructed. So another, if we'll consider about in year 2030, the yet to build is 66% of the total covered area is yet to be built up. So there's a major concern which we need to focus upon, and we need to make consistent energy efficiency and the green buildings which will save our environment and conserve our natural resources. So majorly as we are seeing locally, the changing the trends, because as the human comfort level is also changing day by day, and the buildings are growing day by day, but the energy consumption is also growing. So the majorly increasing economy is growth in economy. That is one of the changing trends in India, or the growth in economy, and another is advancement in technology. So the daily new HVAC technologies, new building materials technologies are coming up day by day. So these are the things which are actually affecting our population, our building scenario, and energy consumption. So there we have to conserve the resources as well as energy. We have to make conservation of water efficiency, sustainable site, materials and resources, indoor air quality, and the emerging lifestyle, which are the major challenge. And these are the, because of this changing trend, the major changing technologies are coming up. So after the emerging technologies in HVAC in different sectors, as we are seeing locally, the glass buildings are coming up. Glass building is everywhere, whether we are constructing building in US, whether we are building constructed in Bangalore, or whether we are constructed building in Mumbai, Delhi, or in the northern part of India. So all the side we are seeing these changing trends. The buildings are constructed as a glass buildings. So these are one of the green worries. Cities face challenging of providing higher level of comfort to providing resource efficient ways, because as I already mentioned, the resources are typically efficient, and the resources are not enough to provide to cater the needs of increasing demand of the population and increasing demand of the consumption requirements. So what we need is, the building are responsible, actually buildings are responsible for 40% of the energy use, 30% of the raw material use, and 20% of water use, and 20% of land use. So these are the responsible, buildings are responsible, because everything, every resources are consuming by the peoples, the living in that buildings, whether we are constructing in any part of the area. But they cause 40% of the carbon emissions. Do we know? Because to conserve, to save 1 unit of energy, to use of 1 unit of energy consumption, it will affect 800 grams of CO2 in the environment. So which is creating big challenge to save and conserve our environment. So the first of the part is to reduce the global emissions, to reduce the carbon emissions of in the environment, which are creating major impact to the climate change, as we are discussing in the daily talks, as the climate is changing. Because before commencing to the summer season, everybody talk about there is so hot outside the environment, still the summer is not coming. So the majorly challenge is the environment responsible things are changing day by day. So now we have to conserve it, but the buildings will cause 40% of the carbon emissions, and 30% of the solid waste generation, and 20% of the water effluents. So these are one of the major challenges which we need to conserve, and major focus on these areas to make the building best energy efficient, best water efficient, and another resources which are related to green buildings. So another is, what are the construct of our cities? So this is just one of the example. The buildings are constructed in Gurgaon, and you can see every curtain in front of windows is completely covered. So there is no use of windows when we'll talk about energy consumption, because the direct solar radiations are directly impacting on the interior part of the building, due to which the energy efficiency, the energy consumption demand is also increasing. So this is one of the bad examples which we are actually seeing, which are actually try to build up like such buildings, but these are not climate responsive and environment responsive buildings. Another is same. This is one of the buildings which we can see in the Gurgaon area in the northern part of country. So another same example. The curtains are again covered up all the windows. So another, there is no use of windows, and like such areas where we are providing individual air conditioning provisions, individual air conditioning and evaporative cooling systems to individual rooms and individual spaces of the interior part of the building, which is also causing increasing demand of energy consumption, and another resources which are actually affecting the human population, which are which makes affecting our productivity, which makes affecting our comfort level. So these are the things which we need to protect on. So the majorly further importance is the buildings importance, where the buildings are important. Buildings are an important component of infrastructure as well, because in the buildings everything will be consumed related to energy, related to sustainable landscaping, water efficiency, solid waste management, and another is indoor air quality, and another is material and resources. So these are the different key parameters which constitutes buildings, and they are actually important and major component of the infrastructure as well. So another is what will be the things which can reduce our and protect our resources. Another is green buildings and sustainability. Sustainability is to procure to save our resources for the future generation. The basically green buildings are economically and efficiently use of resources. Every resources in the buildings, whether it is any way to use in economically and efficiently use of resources. So green buildings play a key role in creating an environmentally sustainable infrastructure. And the green building is not just a local industry trend. It is not specifically for just for green factories or green transport, green metros, everything, whether we are creating green homes, whether we are creating green factories. So everything we need to make it, the building should be creating and protecting our natural resources. So another is what they can impact on the environment and infrastructure. It is a part of actually global push to create sustainable infrastructure that will support growth, that will support the challenging trends in the industry. So now we'll come on to what will be the what are the green buildings and where it is actually focused upon. So what is green building? Green building, I just can say in one line, is economically and efficiently use of all resources, the resources, natural resources, or another resources which are consuming in a building, which are using in a building. So green building or sustainable design is the practice of increasing the efficiency which buildings and their sites use energy, water, materials, and of reducing impacts on human health and environment for the entire life cycle of the building. So this is in one line we can say everything we have to make actually focus upon, which creates energy efficiency, which creates water efficiency, which creates material efficiency, and the reducing impacts on the human health and the environment for the entire life cycle of this building. So in one line, efficient and economic use of resources. So another is why green buildings are required, why green buildings are majorly where it will be impacting. Another we are seeing, and we are talking about climate change, we are talking about increasing energy consumption, and we have already talked about, we have already discussed about 1 kWh. If we are using 1 unit of energy, it will impact 800 grams of CO2 to the environment. So which is creating bad impact, and to which focus on the preserving are these resources. So green buildings will create and contribute to serious environmental and economical problems because of excessive consumption of energy and other natural resources. So these are the things where we have to focus and make major attention to these resources, whether it is environmental and economic problems. And another is it will help to control global emissions of the greenhouse gases, the CO2 gases, which are impacting and bad effect on the environment. So these green buildings will help to control global emissions. And another is green building will reduce operational cost, energy import, and the pollution. The energy resource, the natural resources which are using to generate electricity are coal, natural gas, petroleum, and these resources are actually depleting day by day. So to conserve these, green building will create impact on the reducing environmental and operational cost, which also conserve for the pollution less environment. Another is regulation taking shape to lower the threshold level of water and energy requirements and minimizing waste, because every state and every country is focusing upon the water efficiency and energy efficiency, including the waste, minimization of waste. So every state is focusing about where we have to water efficiency, where we have to conserve energy, where have to conserve, and minimizing the waste generation. So this whole will improve our comfort level of the building for the productive employees, whether we are constructing green buildings for offices, whether we are green building for factories. So in another way we can say a green building is one which uses less water. Less water optimizes energy efficiency, and it conserves natural resources, and it generates less waste, and it provides healthier space of occupants. So in another way, we can say a green building where we have to conserve every resources. So green building is the one where the every resources either related to water, energy, natural resources, waste. So it is the one which use less of all of these resources. And how do we effectively use Earth's infinite natural resources? Whether we can say we can conserve our existing energy consumption, or we can say we can generate energy from the natural resources which are already available in the environment, and which are sunlight, which is solar power, which is wind power, biomass, hydropower, and another renewable energy, renewable sources of energy. So we can also conserve, and we can also take help from these natural resources to generate energy demand, to meet the increasing demand of energy consumption. And to how do we conserve Earth's in finite natural resources, that is coal, water, virgin wood. So these are the things which we need to conserve on a daily basis while we are constructing or designing any green buildings. So another is what will be the benefits, and what will be the impact of the green buildings. Actually, as we already discussed, buildings have a large impact on the environment, human health, and the economy. The successful adoption of the green building development can maximize both the economic and environmental performance of the buildings. So this is the one which is successful adoption of green building development, which can maximize both the economic and environmental performance of the buildings. So these are three different major concerns while considering for the green buildings and sustainability provisions. One is economic benefits, another is environmental benefits, and another are social benefits. So majorly under the environmental benefits, majorly we have to focus upon to protect biodiversity and the ecosystems. Environmental concerns are improve air quality, improving water quality, reducing water streams, and to conserve natural resources. So these are the things which are actually benefits to the environment, and it will be considered as a major concern while constructing of green buildings. So these are the benefits under the environmental impacts. If we are talking about social responsibility, social benefits, it will enhance the occupant comfort and health, and the heighten aesthetic quality, which will improve the aesthetic. And another is minimize strain on the local infrastructure. It will directly correspond to the community connectivity. So every green building should have all the resources should be available nearby to the building where it is designed and constructed. So these are the social responsibilities, are minimum strain on local infrastructure, and it will be improved overall quality of the life. So these are the social benefits which will be corresponds to the green buildings. And another are economic benefits, because everything relates to the cost factor. So it needs to maintain correlation between the economic, environmental, and the social benefits. So under the economic benefits, we can say it will reduce our operating cost, because when we'll design a green building, it will majorly impact on the operating cost and the capital cost. Because if we'll consider about capital and we'll make a comparison between the capital cost and operational cost is 30 to 40% higher than the capital cost. So if we'll increase our if we'll a certain level, if we'll increase our cost at a capital cost to certain level, then we'll definitely reduce our operational cost to the 30 to 40% or even 40 to 60% when we'll consider a building for the energy simulation part, energy efficiency part, including all the parameters. So the operational cost of the building will definitely impact 30 to 40% reducing energy consumption, and same it impacts to the water and another waste and indoor air quality. So these are the economic benefits. It will reduce operating cost, and it will provide tax benefits and subsidies for green buildings and renewable energy concepts. Because in India we can see in the different part of the country, in different part of the states, the government is also providing green building incentives. The owner or the applicant, any architect who will design and who will construct the green buildings, the government will also provide tax benefits to the owner. As in Rajasthan, in Kolkata, in Punjab, in Haryana, there are different green building incentives are also being provided by the government. In Rajasthan, in the 5% extra FAR floor area ratio is being provided by the government. Same in the Kolkata. In Punjab, in Punjab state, for green buildings, 5% extra FAR is being provided for the Griha, LEED, and IGBC, which are different rating system operating in the country for green certifications. So 5% extra FAR is being provided in the Punjab state, and in Haryana, up to 18% of extra FAR is being provided for the green buildings. So for the Griha certification, for up to 18% extra FAR is being provided. So it's a major benefit to the owner, to the occupant who are actually designing and who are actually constructing the green buildings. And another is to create, expand, and shape market for the green products and services. So somehow we are required to make green buildings, but we are not much aware of the resources, but not much aware of the materials which are locally available in the market and which constitutes to which correspond to less energy consumption, less water consumption. So it will create and expand our shape markets for green products and services. It will locally aware to the people, so that every building, everybody can design and construct according to the consideration of that environment responsible materials. And economic benefits is improve. So as in the all parameters, we can see whether it is environmental, social benefits, and economic benefits. We will also discuss about the improving occupant productivity. When we'll discuss about office buildings, when we'll discuss about factories and another commercial buildings, whether it is malls, hotel, and hospitals. Whether it is malls, hotel, and hospital, we'll also consider about improving occupant productivity, because it is one of the major challenges when we'll discuss about major high-rise buildings for green homes, whether it is for office buildings, we need to improve occupant productivity. So these are the major benefits it constitute: environmental, social, and economic, to further constitutes of a green building. Another is what will be the impact of green buildings. As we are already mentioned, it will reduce water efficiency, it will reduce energy efficiency. So how much and how maximum it can reduce? It can actually, green building can reduce the carbon emission up to 35%, and the water use, water efficiency, it can maximum up to 40% reduction in water use, and the building which can reduce 50% of the energy consumption in the green buildings, and the 70% of the solid waste management, solid waste actually, where it constitutes of the total 70% maximum for the green building. So these will be the major impact when we are designing and construction of green buildings. Another is, what are the different classification where where it can be used. So everything in IGBC, in Indian Green Building Council, in GRIHA, Green Rating for Integrated Habitat Assessment, and in LEED, Leadership in Energy and Environmental Design. So these are the three rating system majorly working in India, and another another, when we are discussing about globally, there are different or more rating system are also available. That is Green Mark, Green Star, EPEC standards, because that are locally, regionally configured these energy codes where we are discussing. And in India, there is also one ECBC, Energy Conservation Building Code. So it constitutes overall impact on the different type of resources and different type of building. When we will discuss about green classifications, whether it will be green homes, green data centers, whether it is group housing complexes, green factories, green existing buildings, green interiors, green new buildings, green townships, green metros, green healthcare, green campus, and green cities. So as we already mentioned, green buildings and can be applied and can be integrated for any of the infrastructure, any of the building facility, whether we are constructing for transport side, whether we are constructing for factory side, whether we are constructing for homes and another office building sites. So these are the major classification, and some rating system are applicable for all of different type of ratings, different type of building, different type of classifications. Some of the rating system, and some of the rating system is directly focusing upon the homes, hospitals, existing buildings, and the group housing complex, green homes. So another rating system are also just providing 3 or 4 rating, but in IGBC, Indian Green Building Council, there are different rating system is also covered every classification, whether it is of any kind of buildings. Another is, what is complete overview of the green building, how the building will constitute every specific parameters. As we can see in the buildings, in the first left side, the proper building orientation for best utilization of daylight. So the building needs to be designed and constructed in such a way that the building orientation is like that. The daylight, proper daylight, we can use proper daylight which is available as a natural resource. We can use that, and it can reduce our lighting consumption and energy consumption, and it reducing the need of artificial lighting. Another is the glazed north facade to take in glare-free north light. So as we can see, the majorly light impact on the south and west side. So in the north side, we can use any type of single glazed glass and glass parameters, and in the west side and the south side, where the solar radiation is directly impacting on the buildings through whether it is through windows or whether it is through the roof and walls. So we need to make the building in such a way that the less solar heat and less solar radiation directly impacting on our buildings. Another is what will constitute to the water conservation. Yeah, the buildings should use of rainwater harvesting, and it will be use water efficient fixtures and use of sewage treatment plants. Sewage treatment plants will use further, we can use gray water and black water when we'll reusing the different type of water resources. We can consume it in toilets, or we can use it in kitchens. So these are the different resources which we can constitute to the water conservation. Another is waste disposal, and another is building management system. The building that are smart buildings, which is making parameters that the metering and monitoring of the system. Every meter, every part of the building system, whether it is consuming water, whether it is consuming energy, whether it is consuming waste, everything needs to be properly managed and properly monitored, so that it corresponds to less energy and less water wasting in the buildings. And another is to prevent indoor air quality problems, to enhance the comfort and well-being of the occupants. Another is zero use of CFC-based refrigerants. As we are using air conditioning system in the building, interior part of the building, there are different type of system, whether we are using split ACs, whether it is we are using Windows ACs, and VRVs, VRF system, variable refrigerant flow. So we need to make customization of and to correspond to zero use of CFC-based refrigerants in new base HVAC systems. And another is the waste disposal. That building should consume less waste, and it should be properly monitored, and it directly correspond to the less waste. Another is what will constitute to the life cycle of green building. When we'll discuss about consumption, construction, and disposal, while construction of the buildings, it will reducing construction cost to reduce footprint and reduce construction cost, because the areas are expanding, because the cities are expanding and the areas are consuming day by day. So it needs to source local construction materials. The building that should be constructed in that area where the efficient use of resources and locally available material should be majorly used, and the efficient use of water efficient landscaping should be used, use of fly ash bricks, aluminium frames, glass, low VOC paints, and the CRI certified carpeting. So these are the things which we need to conserve, and which we need to make use of that building when it is the construction phase. And when we are consuming means after post occupancy, savings during consumption. When we'll discuss about environmental control, it will use the optimum use of the daylighting and the maintaining minimum air quality, which will affect on the natural airflow, installation air handling units, and control air exhaust. So the proper ventilation, proper indoor air quality should be maintained in such type of buildings, which will improve our productivity, which will improve occupant comfort levels as well. And environmental control is use of LED. Instead of conventional lights, we should use CFL lighting and LED lightings, which will also reducing energy consumption and improve our glare level of in the interior part of the building. Another is the water management. Water management we'll discuss is rainwater harvesting, water efficient use of water efficient fixtures, water treatment, recycling, and minimizing disposals. So these are the things which are correspond to the post occupancy in the buildings. Another is disposal. When we'll discuss solid waste control strategies, ingress protection, preventing dust and external elements from entering the buildings. Another is grey water handling. So while reusing the water, where we can use is we can use the reuse water in landscaping, we can reuse water in toilets, we can reuse water in kitchens. So these are the things which we can use, which we can correspond to concentrate for the designing and construction of the green buildings. So these are the overall life cycle of the green building, whether it is construction stage, post occupancy stage, and the disposal stage. Another is what are the different components of a green building. In a green building, as already discussed, one is site parameters, another is water parameter, water efficiency, another is energy parameters, another is materials, and indoor air quality. So these are the things which constitute, actually these are the different component of a green building. In the right side, you can see sustainable site planning, water management, energy optimization, sustainable building materials, health and well-being is also one of the prime focus area where we can use while sitting in the office buildings. So health and well-being are also one of the major criteria, because when we are discussing about indoor air quality and the natural ventilation, it will directly correspond to use the fresh air from the outside. But what we can do while fresh air, the outside air is already polluted, because in the cities like Delhi, in cities like Bombay, the different indoor air quality, outside air, the fresh air is also being polluted in that cities, because the different pollution from the buildings, different pollution from the transport, different pollution from the different type of sectors which are already polluting the environment. So this is also one of the major parameter while constructing our green building is health and well-being. Another is building operation and maintenance. So is the building, we have to check is the building is operating as per according to the design parameters or not. Is the building as per the design it is being constructed, is it being in the running position or not. So these are the parameter which will be constructing. So firstly we'll discuss about site related parameters. When we'll think upon green buildings, what are green buildings, and when we are going to design and construct green buildings, so environmentally sensitive sites must be avoided. So that areas where already green areas are also promoted, and green environment is also concentrated and focused upon, so that site should not be displaced, and that site should not be discontinued to make man-made jungles to the constructing concrete jungles. There is environmentally sensitive site must be avoided, and another is proper erosion control measures. One is topsoil preservation. When we'll construct a green building, we need to conserve and protect topsoil of the topsoil layer of the site area, and another is construction of sedimentation tanks. When we are using the water, a sedimentation tank, such kind of sedimentation tank should be constructed in such a way that we can use while construction, while further construction of the buildings, and the air pollution prevention. We can use the water spraying on the roads, because when the building is being constructed and when the building is going to be constructed, the water, different type of truck building materials, the overlaying trucks are actually running on the sites, which will create erosion of the topsoil. So that it needs to maintain conservation is topsoil is being conserved, and the water spraying on the roads where from the entering area where the trucks are entering. And another is site related parameters. It needs to be designed in such a way to maximize the open space. The open in the first figure we can see it needs to be designed in such a way that the maximize the open space in the site area. Another is it will be to reduce impervious areas, which will increase the overall runoff of the water from whether it is from roof, whether it is from non-roof area to the rainwater harvesting pits. Another is we can use green pavers. We have to conserve protect the existing trees, because the building whether it is constructed in that area, the trees are also existing. Then we need to procure it the different site area in the different location that needs to maintain ecological site parameters, and it needs to maintain proper existing trees. Another is to stormwater management. Stormwater management is also one of the major parameter related to site related parameters to construct green buildings, and another is to design to reduce heat island effects. So these are the things which we need to focus upon for these site related parameters. Another is design with the minimum disturbance to the existing features. As I already mentioned, the design with minimum disturbance is as the trees are already existing in such a place, so that we can use in the another part of the building, but it should locally ecologically site purview should be maintained. So another is natural water bodies and the trees should be properly maintained. Another is water efficiency. In water efficiency, when we'll discuss about the reduction in water during construction, whether it is building in the construction stage, whether the building is in post occupancy stage, the water efficiency should be the prime importance, where the water conservation should be more and more. And another is reduction of water usage post occupancy. So these are the three different parameters. One is reduce, reuse, and recharge. So these are the different parameters constitutes to the water efficiency. The water should be reduced, and water can be reused, and the water can be recharged as comparison as in purview of rainwater harvesting pits to the recharge. Another is water efficiency to the post occupancy constructions. When we will discuss about use of low flow fixtures, that fixtures actually correspond to the low flow and minimization of reducing of water efficiency, reduce water flow fixtures. Another is rainwater storage, rainwater harvesting pits. Another is STP, sewage treatment plants, use of treated water for landscaping and flushing, and water efficient landscaping, use drought tolerant species, efficient management of irrigation systems. When we are using irrigation, so we can use drip irrigation systems, sprinkler systems to uh, to provide completely water to the landscaping, to the existing site parameters, to the site landscaping of the site area. So these are the things which we need to focus upon for the post occupancy correspond to the water efficiency. So low flow fixtures and rainwater harvesting are the major concern. In some of the states, rainwater harvesting is mandatory. When you are designing any building, whether it is conventional building or whether it is green building, rainwater harvesting is mandatory for all the buildings. In some of the states, it's already been mandatory. Another is water reduction. It is during construction. During construction, use of jute bags. When to provide proper water to the existing construction during construction phase, use of jute bags for curing. So it will use of less water and to provide complete strength to the pillars which are being constructed for a particular building. So use of jute bags for curing and RCC coffer blocks stacked in a foam to utilize water curing by water spraying. So we can use the complete blocks, AAC blocks or RCC blocks should be stacked in such a way that the water spraying to those blocks should be such a way that the water can be used, minimized. And the reuse of captured rainwater. So another it to maintain is energy efficiency. When we are discussing about energy efficiency, as I already mentioned, in Energy Conservation Building Code, ECBC is already mandatory in some of the states. Currently in India, there are 10 states in India where ECBC is mandatory. When any building is going to be constructed, which are having sanctioned load or connected load of above 100 kilowatt, that building should be ECBC compliant. Otherwise, the building plan sanctioning approval are not allowed in some of the states. So to maintain that, and to implement Energy Conservation Building Code in designing and construction of the buildings, so the major parameters and the major concerns should be such a way that the building proper orientation, because proper orientation is such a way that the major longer facade is east-west. Longer facade of the building is east-west axis, and the minimized use of the glass in the south and west part of the building. So these are the major concern while we are doing for the building orientation. Another is energy building efficient building envelope. One is the proper shading. That's proper shading, whether it is through trees, whether it is through overhangs, and whether it is through any sustainable materials which were used in the buildings. Another is glass. So the minimization of the glass in south and west part of the building, because solar radiation are directly impacting on that side only. So we need to maintain that glass which imparts less solar radiation, less heat to that part of the building. So the double glazed glazing, instead of the single glazed units, we need to maintain double glazed glass in south and west part of the building majorly. Another, we can say we can use double glaze in all part of the building, but in the north and east, it impacts less. So we can use glass as major as a energy efficient. Another is walls and roofs. What we can do while designing and construction of the buildings. In walls and roofs, there are different parameters. While we are using red bricks, instead of red bricks, we can use fly ash bricks, AC blocks, hollow blocks, and perforated blocks. So these are the different things which are being used while designing and construction of the buildings. These are the blocks. Another is insulation, whether it is glass wool, rock wool, EPS insulation, XPS insulation, puff foam, puff slab, puff spray. So 7, 8 different type of insulation materials are also available, which should be used while while designing and construction of walls and roof of the building, which actually impart less energy to the interior part of the building and correspond to maximum energy efficiency. Another is efficient HVAC equipments. In energy efficiency, all the different parameters, whether it is orientation, proper shading, glass, HVAC equipments, renewable energy, and artificial lighting design. So these all the things which are comprises of total energy efficiency. Efficient HVAC systems means that systems must be minimum 3-star, minimum star rated equipments, or the minimum equipments having minimum COP levels. COP is coefficient of performance. That is minimum efficiency level that should be running at operational at minimum efficiency levels, which are being defined in ASHRAE 90.1. As we are designing that building, green buildings, we have to refer ECBC, either ECBC or referred ASHRAE 90.1. So another is efficient HVAC systems, whether we are using VRV systems, chill beams, geothermal cooling. So we need to maintain that pumps should be VFD integrated pumps, that systems should be energy efficient systems. Another is use of renewable energy. Renewable energy, we already discussed solar energy, wind energy, hydro, biogas, biomass. So these are the systems which we can use, because in India there are different such system. I would like to mention some of the things which are also waste to energy concept is also being upcoming in the state in India. Waste to energy is from the waste generated in the buildings, we can use again to the kitchens for again as a biogas. So these waste to energy concepts are also being upcoming in India, use of renewable energy and efficient artificial lighting design. So the lighting design should be in such a way that the minimum, it should not cross the maximum LPD levels. LPD levels is lighting power density. When we are sitting in any of the rooms, while it is office buildings, while it is factories, while it is any malls or hotels and hospitals, so that areas should not exceed the maximum LPD levels. And it also recommended to use LED fixtures, which increases glare and proper lighting in the interior part of the building, whether it is interior or exterior part of the buildings as well. Another energy efficiency envelope measures, that is typical saving potential. When we are considering orientation, that means that longer facade of the building should be east and west side of the building. And when we are designing windows to the east and west, the major buffer spaces, whether it is staircases, toilets, and storerooms, that should be at the east and west side of the building. Because when the sun rises and the sun sets, that does not impact in the interior part of the building, which will cause energy consumption, which will cause increasing demand of energy consumption. So if we'll consider that orientation measures will increase 0.5 to 1% in increase in the saving potential. When we are using AC walls, AC bricks instead of the red bricks, instead of the fly ash bricks, we can instead of concrete blocks, we can use AC blocks. It will increase saving potential of 3 to 8%. And the brick wall with 75 mm EPS, that is I already mentioned insulation of different types. So EPS is just like thermocol sheet. So that 75 mm brick wall, we can use 3 to 8% of the saving potential when we'll be using high albedo roofing materials. High albedo roofing material is like SRI paints, heat reflective tiles. SRI paint is solar reflectance index. Solar reflectance index is the solar radiations which are directly impacting on the roof. It will, that material SRI paint or SRI tiles will have the maximum capacity to reflect of more than 90% of the solar radiations, which can directly impacting of the energy consumption. So high albedo roofing materials, we can also use China mosaic tiles. China mosaic tiles is like such a way that the tiles in broken tiles, which are also used in rock garden. As we can see, rock garden, roof garden, we can use it. It will saving potential of 1 to 2%. Low U glass and glazing. When we'll consider glass, single glaze in comparison to double glaze will have only 20%. It will impart only 20% of the solar light or solar radiation to the interior part of the building. 80% of the heat or solar radiation directly it will reflect. It will reflect back, but it will not impact on the lighting, visibility, VLT part, visible light transmittance. It will not impact on the VLT part. It will impact on heating part. That will impact on energy efficiency and energy consumption. Another is thermal break and roof insulation. Extruded polystyrene, that will impact on 5 to 6% of the saving potential when we're discussing envelope measures. So the building envelope is one of the most critical part when we'll be designing and construction of the buildings. So and when we'll use these all type of parameters, we can also conserve for 30 to 40 and 60% of the energy consumption while designing in such a way that of a building. Another is equipment and systems. Another system will air conditioning, chill or COP. COP is coefficient of performance, that is minimum efficiency levels, that is VFD for supply and return fans. When we will be using any pumps in the buildings, that pumps should be VFD driven. VFD is variable frequency drive. So another is heat recovery wheels, economizers and controls. Controls building and building management system. When we are sitting in office spaces and the cabins, where the interior temperature is required only 23 to 25, which correspond to comfort level of any occupant. When 23 to 25 meets, it will automatically shut down. It will automatically shut down of the system because when we are using energy efficient HVAC systems like VRV and VRF, variable refrigerant volume and variable refrigerant flow. So that system, if in the building 42 rooms, maximum 42 rooms, it can provide proper refrigerant flow, it can provide air flow. In that system, VRV and VRF, only one unit is outdoor unit, and it can connect it to maximum of 42 interior units to the interior part of the building, which can conserve and which can save energy. Instead of we can use 41 separate split ACs or 41 separate windows AC. In comparison of that, it can save 30 to 40% of the total energy consumption in the building. That are VRV and VRFs. Another is chiller systems, district cooling system. When we are designing any townships, when we are designing any big residential societies, we can use district cooling system because one system is being placed at one place, and to the whole society is being provided air conditioning by the only one unit. Another is radiant cooling systems, geothermal cooling. Geothermal is when we'll see to the earth 5 to 6 meters inside the earth, the temperature is constant. In summer, it is that air is colder, and in the winter under the 5-6 meter of the interior earth surface, that air is warmer. So we can use for the institutional buildings where the air conditioning provision is not actually provided to the whole part of the building. So we can use that air, that circulation for the educational building, for the institutional buildings, to maintain air conditioning of the systems, air conditioning in the interior part of the building. So that is also one of the major advantage of the geothermal cooling. If we want to see, the geothermal cooling is already installed at a ISB Mohali, Indian School of Business Mohali campus. A geothermal cooling has already been installed. And in the earth air tunnel, if we can see Decrust Murthal, Deenbandhu Choturam University of Science and Technology, earth air tunnel is being used to provide air conditioning to the interior part of the zones. So these are such innovation technologies, innovative type of technologies which can use less energy consumption, less energy. We should use that energy efficient HVAC technologies because it consumes more and more energy consumption. HVAC systems consume around 40 to 60% of the total energy consumption in the interior part of the building. And another is lighting. Energy efficiency, and another energy efficiency part is lighting. Provide automatic controls. When we are sitting in conference rooms, cabin rooms, meeting rooms, another we can use automatic controls, whether it is like occupancy sensors, whether it is like daylight sensor, motion sensor, astronomical time switch. What will do occupancy sensor? When we'll come back, when we're sitting in the conference area and meeting area, cabin rooms, that light is automatically switched on. When we'll leave the space, when we'll leave the room, that light will automatically shut down, switched off. So these systems, these sensors, which will reduce the increasing energy efficiency, and it will correspond to increasing energy efficiency to the lighting part of the systems. And to maintain minimum LPD, whether we can say minimum LPD or it should not cross the maximum LPD level of the interior part of the building. Another is separate controls for separate lighting. Whether some of the lightings are LED lighting, some of the lighting are CFL lighting, some of the lightings are display lightings, hoardings. Different lighting for the separate control should be provided for the separate lightings, and the energy efficient lighting fixtures and it will be recommended to use LED fixtures. LED fixtures we should use, which can reduce the increasing demand of energy consumption. So that the fourth part is material efficiency. So as we already discussed, one is site related parameters, then is water efficiency, another is energy efficiency, and the fourth part of the measure is materials efficiency. When we use any materials, whether it is at the construction stage, whether it is at the post occupancy stage, the materials should be properly used in such a way that it will not impact on the human comfort, and it will not impact on the human productivity. So proper waste management within the buildings, proper construction waste management, when we'll be using fly ash bricks, when we'll use scrap yards, whether it's for wood, paper, waste, bricks. So the different sections should be provided for the to collect different type of waste, so that it can be further reused old materials, and the further is used material with recycled content. That material we should use which has more value of recycled content. As we can see, FSC certified wood. FSC certified wood is Forest Stewardship Council. That is a council from where the wood is being certified. So that wood we should use in the green buildings. That material has already been used, constructed with the recycled contents. And the fly ash bricks are also constructed with the some cement materials and some recycled content of the materials, and use rapidly renewable materials like cement bags, cement polyesters, cement bags. We can collect in such a in proper manner in a single place, so that it can be further reused to boarding and lodging of the different type of materials. So these are the different. Another is use fly ash bricks, as you already discussed. Use of PPC for concrete and masonry blocks. Use low finite granite AC blocks. For no non-structural application, prefer lightweight concrete blocks, perforated modular bricks. So these are such type of material which has already some recycled material content, which can reduce the which can increasing waste efficiency. And another is products manufactured with the resource efficient process, including reducing energy consumption and minimizing waste and reducing greenhouse gases, which are the major impact environmental benefits of the green buildings. Another is that building material found locally. All the material should construct while construction of the building, all the material should be available and should be locally regionally materials. That material should be locally available, locally regional material should be used while construction of the buildings, and it will save energy and resources in transportation. It will reduce the energy, it will reduce the fuel to transport the material from one place to another place, so that we can use the building materials. Another is waste management. Waste management is during construction or waste segregation to different part of the system, like waste on site to be segregated into inert, chemical and hazardous waste. So different level of hazardous waste to the different type of chemical should be collected in different type of systems, and waste management should be segregated during construction. And another is chemical and hazardous waste to be recycled. Another is inert waste to be disposed of to the landfills. Waste segregation is different colored bins for different type of waste, whether we are using organic waste, dry waste, wet waste. So that material, that bins should be provided for the different separate bins should be provided for to collect for the different type of waste, which constitutes waste segregation, and it will increase waste management. Another is allocate separate space for waste collection and transfer. So in the examples we can see the old wood from demolition of a building has been used in the new building. So if we'll conserve, if we'll that materials we can reuse to the another part of the building when we'll construct any new part or any simple sample spaces of the building, we can construct the older material which has been constructed while during construction of the buildings. So these are the different parameters which can constitute to waste management in the buildings. So majorly another impact is the indoor air quality. Indoor air quality is that the minimum quantity of fresh air must be provided. So all the areas, all the room, whether it is big conference room, whether big hospitals, where it is need to maintain the fresh air from the outside, from the environment. So the minimum quantity of fresh air must be provided to maintain minimum airflow in the interior part of the building, to provide comfort and to increase occupant productivity. Another is to monitor carbon dioxide, CO2 level. CO2 level should be monitored in the interior part of the building. That should be monitored when we'll design green buildings. It is also one of the major part of the indoor air quality, where we have to focus upon the CO2, maintain CO2 level in the interior part of the building. Another is no smoking building. So no smoking zone, whether all the building should be no smoking, or no smoking zone should be separately provided in the building. Whether no smoking provisions in the building or smoking zone should be separately provided in the site area of the building. Another is low VOC material. VOC is volatile organic compounds. That material should be used, like that VOC paints should be used, low VOC paint, which will impact on the occupant productivity and occupant comfort level, and it will not impact on the human levels. Next is thermal comfort and daylights and views. So these are the two different type of parameters, daylights and views. Indoor air quality, when we are using exterior light, natural light from the outside of the building, natural light and daylight and natural views we can use to the interior indoor air quality. Another is health, well-being and environmental quality. So this is also one of the major constituent of the green buildings, that is providing provisions of health and well-being of construction of workers. Another is safety helmets, boots, masks. So these parameters should be used while construction of the building by the construction workers. Separate boarding facility, separate mask, separate boots. Everything should be provided. Separate medical facility should also be provided when the building is being constructed to provide occupant comfort level, and to the major provide comfort to the construction workers. Use of safety nets appropriately. Then will be construction of the building. Safety net should be appropriately used. Clean drinking water. Drinking water should be provided. Medical facility should be provided. Pakka houses for workers. Some boarding lodging facility should also be provided for the workers, and provision of toilets on construction site. So these are the things which corresponds to the health, well-being, and environmental quality. Well, when the building is being constructed as a green building. Majorly is indoor air quality. As we already mentioned, CO2 level, we have to maintain or monitor CO2 level in the interior part of the building, CO2 and ventilation. So in the first example, case 1, that is poor ventilation. Poor ventilation is inside or outside differential is 1000 ppm. And it is equal to 10 CFM per person. But as per NBC or as per ASHRAE levels, so that CFM level should be 25 CFM per person, which will maintain the proper CO2 level in the building, or to provide fresh air and to provide proper ventilation in the interior part of the building. When the first part we can see interior part of the building is 1400 and the outside CO2 is 400. So the total differential is 1000 ppm. And in the case 2, good ventilation example is when the interior ppm is 930 and the outside CO2 is 400 ppm. Then the differential pressure is 530 ppm, and it is equal to 25 CFM per person, and it should not more than 530 ppm differential with respect to the outside, and it corresponds to better indoor air quality, and it will better monitor CO2 level and the fresh air in the interior part of the buildings. So last in the major component of the green building is building operations and maintenance. Every system, whether it is for lighting, whether it is for HVAC systems, whether it is for water efficiency or waste management, everything should be properly monitored, properly metering, properly operation and maintenance. O&M manual should be provided for post-occupancy levels, post-occupancy in the buildings. So the different measures are provisions of energy and water meter for monitoring consumption. So that meter should be meter should also be provided in such a way to monitor the proper water and energy consumption. Means how much total water consumption is being in a day or week, in a month, in a year completely. So these 3-4 different type of calculation parameters should also be provided in the meters, and the detailed commissioning of all electrical and mechanical systems. Because electrical system, when we are installing, that should be monitored and that should be operational as per design stage. Because as per the design capacity, sometimes the COP levels when we'll install at the building at the commissioning stage, that COP is 5.8. But after running 2-3 years, that in the operational time of the building, after 2-3 years, it will degrade and depleting to 4.2, 4.5. So that COP level, minimum efficiency level, is being reduced year over year. So we have to maintain that detailed commissioning for every year, that the systems, whether it is electrical or mechanical systems, are running as per the design stage, as per the occupancy, as per the design stage in the commissioning stage or not. After the provision for a core facility management team for conducting regular operation and maintenance activity after installations. Another is development of fully documented O&M manual and listing the best practices. So that building, whether it is green homes, whether it is green factories, green offices, that operation and maintenance manual should be properly prepared and planned to provide better knowledge and further knowledge to the further occupants or the post occupants in the interior part of the building. Another, validating the energy performance of the building post occupancy, post installation in the line with the claims during earlier submission. So these are the things. What are the different measurement and verification for commissioning, energy audits, and to maintain the energy star of the building, how the building are being regulated. So over year, we should use these type of current regular practices, energy audits and B star rating things, so that our system should be properly monitored and should be running as per the design stage. So as we discussed, green building rating system, that are previous are the major components of the green buildings. Another is what are the different green building rating systems in India. So majorly is rating system. First is LEED, which is Leadership in Energy and Environmental Design. It is actually operated by USGBC, US Green Building Council. And but in nowadays, it's also all the projects in India, when we'll registering under LEED, it will be certified through LEED India, because LEED India is also a certified body which will provide certification level, which will review all the documents and will check the site parameter. Site inspection will also be carried out by LEED India team, whether its building is being operational as per the green building parameters or not. After then, the proper green building certification will be provided by these rating systems. One is LEED, another is GRIHA, Green Rating for Integrated Habitat Assessment. So there are different levels as well. In LEED, there are level are certified silver, gold, platinum. In GRIHA, there are different levels of rating system: 1 star, 2 star, 3 star, 4 star, and 5 star. In GRIHA, 1 to 5 star rating system. In LEED and IGBC, USGBC or IGBC, there are different levels of certifications. One is certified, silver, gold, and platinum. So these 4 levels in LEED and IGBC, and in GRIHA 1 to 5 star. So in IGBC, around 4.5 billion square feet of the total in India is actually currently carried out by IGBC, as it had started after 2001. Now in 2018, now it is 2017, and after it is targeted to after 10 billion square feet of around till 2022. So till 2022, they are targeting to 10 billion square feet. So there is a big demand over the commercial building, over the big residential societies, to make that building environmental responsive, that buildings as a green buildings, and to the sustainable point of view, these buildings should be monitored in such a way. But these rating systems are available in India. Apart from these rating systems, some of the rating systems are also available, which is being regulated by USGBC, and that rating systems are WELL standards. WELL, WELL, and another is EDGE standards. WELL is specifically for health and well-being of the occupants, and EDGE is for monitoring of the energy systems. So these two different are also being regulated by USGBC, but only some of the buildings are being taken up for different type of rating system in India as well. So and in the totally globally wise, we can see the green mark, green star, and BREEAM for UK based standards, and USGBC LEED for the US standards. So the different type of rating systems are also available in India as per and globally, to make that building energy efficient, sustainable, and as a certification tag to green buildings. And to the last is, how do green buildings improve businesses? With green building design and operation, business success is assured as building become both practical and profitable, because it will also reduce the operational cost, that will be profitable, and the practical is all the resources in the buildings will be used as of economically and efficiently way. Another, commercial tenants or owner operators of sustainable green commercial buildings see tangible economic benefits including increased rental rates, increased occupant comfort, and increased stock prices. So another is also can provide property value while decreasing operating cost. When we'll constructing green homes, better green societies, where all the systems are better, energy efficient, water efficient, landscape, sustainable site, indoor air quality, that building property value should also increase, will also increase, and it will same parallelly in case it will also decrease the operational cost of the building. And at a public entity such as city or university can make a strides in improve strategies, improve image, and demonstrate to citizens and students that the organization focus on the environmental issues. So this is also a image property, image value is also considered when the green building is coming. Yes, they are focused on environmental issues as well. So these are also a social cause. So another is lower energy use increases competitive edge and return on investment. When we are consuming majorly capital cost, when our building is 8 to 10% in the capital cost is increasing while designing and construction of building, capital cost is our 8 to 10% increases, but the return on investment of that building will be within 3 to 4 years, and the building should have to run for 40 or 50 years longer time of period, which will also provide tax benefits from the government, and it will also reduce the operational cost. So it's a complete win-win situation for occupants, for the comfort, for the owner as well, for the architects as well, and for the social responsibility cause as well. Another is high performance building, increased comfort, productivity, and learning. So these are the major things which corresponds to and constitutes to green buildings. And the major conclusion is two technologies to reduce material inputs per unit of service, reduce your ecological footprint, rainwater harvesting, pay less for power consumption in water pumping, reduce unwanted heat gain, pay less for power consumption in climate control, reduce power consumption, pay less for power consumed in lighting, whether it is lighting or HVAC, reduce garbage disposal, pay less for handling and cleanup, treat and reuse of grey water, pay less for non-drinking water consumption. So everything it constitutes to the less water, less energy, less waste, less handling and less cleanup garbage disposal, and reduce our ecological footprint. So our main objective is to save our planet and to make eco-friendly environment responsive buildings, which will make constitutes to the green buildings. Thanks very much, and the future ends with you.
और इधर ही आ जाएंगे because mic is there. So on behalf of participants and the department, I'm grateful to Mani Khanna ji for and he has given an enriching talk, and especially with the reference to the various green codes and also the various parameters which are very much required for identifying in the for the green buildings, like indoor air quality, water efficiency, energy efficiency, among other issues. So now the house is open for question and answer session. We'll ask the participants from the various centers if they have any questions and queries from the expert. Now, any questions?
Hello.
Yes.
Good morning, sir. My inquiry, is there minimum area defined for green buildings?
No.
Like how many occupants and
No.
suppose there are 100 occupants.
Right. No, actually,
100 occupants.
Okay, so actually there is no any constraint to make any green buildings. We can construct our home as a green building, green home. So we can make our building, our homes as a green home. There is no constraint that building should be green building or there is any mandatory course from the government. And because it is a social and environmentally responsible issue, we can we can implement these type of resources to even to our green home, to make our home as a green home as well.
Okay. Now, for an ideal, if we consider an ideal situation, for suppose for 100 occupants, according to you, what will be the cost of a building which can accommodate 100 occupants?
Because actually it's not depend on the occupants, because it's depend on the systems, what type of system we are using. We are using as a
No.
split AC, when we are discussing about HVAC systems, we're using whether it is split ACs, whether it is using VRV, VRF or geothermal earth air tunnels, different type of system. In lighting system, whether we are using occupancy sensors, lighting controls and LEDs we are using or not. So that is completely not dependent on the occupants. It depends on the facilities we are using and the
No,
equipment.
fine. If we want to sensitize the people, then we need to tell, okay, if we can reduce the energy consumption by so much, if just an example, if
Yeah. Right, that was I already mentioned. When we are constructing any green building as comparison to conventional buildings, there will be a incremental cost with a hike of 7 to 8% as comparison to conventional buildings, or the parameters we are considering to make our building as a green building. So it will impact incremental cost of around 7 to 8% as comparison to a conventional building.
thank you.
Good morning, sir. Sir, I'm the student of architecture department.
Okay.
Sir, I want to know what is U glass.
New glass. What is new glass?
U glass, sir. As you discussed in your slides, U glass. What is U glass?
U value of the U value is a property of material. That glass we can use as single glazed glass, double glazed glass. But when we'll discuss about property of that material, property of the glass, there are two properties. One is U value and one is SHGC. U value is the thermal conductivity. How much heat is transferred from the outer side of the building to the interior part of the building. That is U value. Another is SHGC, solar heat gain coefficient. How much solar radiations is directly impacting to the interior part through windows. So these are two different property of the material. One is U value and one is SHGC.
Okay, sir. Sir, these two values are comes in the U glass, low U glass.
Lower U value, that value should be lower. That property I discussed is that U value and SHGC. That U value and SHGC of that glass should be lower, so that it does not affect the outer heat to the interior part of the building.
But sir, in cold areas we can't use now. We need heat. We need heat from the environment.
Yes, that's what we had mentioned, is that we should to make environment responsive buildings. If we can use, if we can construct that building in Bangalore, that I think we shouldn't use double glazed glass in every part of the building. So we have to construct, we have to design every building as per climate responsive, environment responsive buildings.
Okay, sir. Thank you.
No questions, ma'am. Thank you. No questions, ma'am. Thank you.
Thanks. They are a very important job. So now we will break for tea and after and it will come in outside. And after the accept. And the second for environment. That is the B. Right? So at the all the centers that they should they and the next
Thank you. So good morning, everyone. In this session, I'm going to talk about environmental instrumentation. So we know about till today in this 5 days training program, we have come to know what is environment. It is basically interaction between the living and non-living things, which is very much required for our ecological cycle. And also what are the various environmental pollution, what is pollution, which is unwanted waste, or other contaminants which are there in the different components of our ecosystem like soil, water, air, and so on. And how does it affect our health? That has also been covered by the various speakers, and also during the various sessions with regard to like there was a session with regard to water, with regard to soil conservation and erosion, with regard to that genetically modified crops. So all and other sessions also, they focused that they also highlighted the various problems which were related to the pollution. Now to know about the pollution and to take the remedial measure, then we have to measure what are the various quantities of different parameters related to say air pollution or water pollution, etc. Only then we can take appropriate measures to rectify or for remedial measure to contain that particular pollution. And for that is very important if we want to if we want to control all these problems. For that we require certain instruments. So these type of instruments which helps us to determine what is the quantity and what type of pollution is present in a specific component of our environment. For that, environmental instrumentation are being used. Now, what is instrumentation? Instrumentation is the measuring instruments which are used for indicating, measuring, and recording physical quantities. Since you know that whenever we talk about air pollution, we want to know what type of gases are available there, what is the quantity of these gases. In water pollution also, what type of salts or maybe what type of metals like lead is there, might be present there, which is harmful to human health, or maybe certain type of salts which are harmful to human health, they are also present in excess in water. Then how to determine these quantities? So these are the physical quantities, and we generally what happens is we transfer them to quantities which as a person or as a scientist or as an engineer or as a human being, we can easily observe, and we can understand that what type of problem is occurring at a particular site or particular place. So what happens is the basic component of any instrumentation, one is whatever we want to measure, it is a physical phenomena like temperature, pressure, or certain amount of pollutant which is present at a particular place. Then there are sensors and transducers. Now the function is of the sensor is to sense what, for example, if there is a certain change in the pressure. So how much pressure is there? Yeah, how much temperature is at a particular place? So that is the physical quantity which a sensor measures, and they are all sometimes also known as transducers. Transducers are basically that practically components which transfer the signal from one form to another. Generally, it is transferred from, say, physical form to electrical signals. For example, a transducer which you might be commonly knowing is photodiode, where light is converted into, through semiconductor type materials which is used as a sensors or transducers, it is converted to the electrical signal. So depending upon the amount of light, the proportionate amount of electrical signal is given. Similarly, if we want to measure the pressure, then piezoelectric materials are available. So what is the pressure? Depending upon the amount of pressure, we get the electrical output. So so these are like this electrical. We see the application of pressure, then for when we want to measure the sound level, right? Because as you might have known from the previous session, that if the sound level is greater than 80 decibels, then it comes under noise. So how to measure that? For that we use piezoelectric material or that type of transducer. So it measures, because you see what is sound? It is a wave which has a characteristic of pressure and displacement. So whenever the sound level is there, some pressure is created. So that sensor senses the extent of pressure, and accordingly converts into the electrical signal. Now, once these sensors, it senses the type of physical quantity which is being measured and converts into suitable electrical signal, then signal conditioning takes place. There is a circuit of signal conditioning in any instrument. So what happens is, here we generally amplify the signal, and we generally we also go in for filtration of the system and linearization of the signal. Filtration of the signal, amplification of the signal, because the signal which is produced from the transducer, it might be of a lower level, so it needs to be amplified, right? And some unwanted frequencies also need to be filtered, so that is why we use filtration. Now then, we convert the signal from analog quantity to digital quantity. So generally physical parameters are measured, they are in the analog quantities are available, then these are converted for digital conversion, and thereafter with a certain processing, then with the interfacing, we display the measurement, whatever is there, in a suitable form, which can be stored also, or which is observable also, depending upon the type of data which we are recording. Now, what are the various type of instrumental instruments which are required for measuring the environmental instrumentation, and what do these instruments are used for, in what type of analysis? Now, environmental instrumentation, it basically focuses on study of relationship of instruments and methods which are used to separate, identify and quantify the matter. So what happens is, we want to analyze what is the composition of a sample of a matter. Suppose there is a air, we want to see how much is the impurities which are present in a, or pollutants which are present in the sample of air. Or if there is a water sample, we want to measure what type of salts or other metals are present in that. So we want to see what is the composition of sample. For that matter, we employ the instrumentation. Now, there are two types of analysis when we go in for environmental instrumentation or any type of instrumentation. One is qualitative, another is quantitative. Qualitative analysis indicates the presence or absence of one or more components of the sample. For example, if we are testing a lead in the water, so first of all, we should know whether any lead is present. So if it is present, then we will go in for further analysis, that is quantitative analysis. We want to find out what type of contaminants or pollutants are present in the particular sample. For that, qualitative analysis is done. Another is the quantitative analysis, where we want to know the quantity of the particular substance which is present in the sample. Now, instrumental analysis, it is a physical property of the substance which is measured to determine the chemical composition. Now, the choice of instruments depends upon the property which is required to be measured. There are so many types of instruments available. Now, which type of instrument we want to employ? There are certain physical quantities which are measured, which are based on certain phenomena, right? According to which we can analyze the particular for particular quantitative analysis. So, depending upon that, we employ the suitable instrument. So, basic principle of an instrument is it consists of an analytical method which is used to establish the pollutant concentrations. Another thing which needs to be known is that any single instrument, it cannot solve or it cannot find out analysis of all type of components in a sample. Instead, several instrumental techniques are required when we carry out any study with regard to environmental pollution. In instrumental analysis, a physical property of the substance is measured to determine its chemical composition. So generally, there are various types of properties which are measured, and certain methods are employed depending upon the properties which is required to be measured. For example, if we want to measure the mass of, say, we want to measure how the total dissolved or total suspended solids, dissolved solids in a water sample. For that, we use gravimetry method, which you might be knowing that we generally evaporate. One of the simplest method is we just evaporate the water and we measure and we then weigh what is the residue left over. So that is the gravimetry method to find out TDS in the water. Then volume, that is volumetry method is used, that you also might be familiar with. The titration method was generally being used, right? That is volumetry. Then another is electrical conductance, in which electrical potential is measured. Another properties which is measured when we want to understand about the pollutant, conductometry, and the method uses potentiometry, absorption, and there are certain instruments which are dependent upon the interaction of electromagnetic radiation with the substance or sample of a particular type of species of the sample which we want to measure. So that is dependent upon the how it behaves when it absorbs the electromagnetic radiation. Then the method involves ultraviolet, that is UV, generally known as visible and infrared spectrophotometry or atomic absorption spectrophotometry. Certain properties which we measure to find out the quantity or the qualitative analysis of a particular substance. Here emission of radiation is measured, and the method employed is emission spectroscopy and flame photometry. In certain type of analysis, we also try to look upon the scattering of radiation. Here the method uses nephelometry and turbidimetry. So I am going to, so these methods can be divided into two parts. One is classical or chemical methods, where gravimetric and volumetric methods comes under this type of category, and rest of the methods are known as instrumental methods. In the instrumentation, although there are a variety of other methods are also being involved, but in this particular session, it will not be possible to go into deeply into all the methods which are being employed for carrying out the analytical instrumentation with regard to environmental pollution. Now, the type of the methods which I am going to discuss in the session will be those methods which are generally employed and mostly being used for environmental pollution analysis. Now, one is nephelometry, another is turbidimetry. Next, I'll discuss about is atomic absorption spectrophotometry, emission spectroscopy, and flame photometry. Now, nephelometer and turbidimeter, they basically depend upon the scattering of light. So, whenever the electromagnetic radiation, it strikes a particle in a solution, some of the light will be absorbed by the particle, some will be transmitted through the solution, and some will be scattered or reflected. Now, the amount of the light which is scattered is proportional to the concentration of the insoluble particle or the contaminants which is present in the sample. The turbidimetry and nephelometry, they are based on the principle of the light scattering. So, generally these methods are used for detecting smoke and dust in air or for finding out the turbidity in the water. In nephelometry, what happens is we measure the intensity of scattered light, while in turbidimeter, the intensity of light transmitted to the sample is measured. In nephelometry, as you can see in the diagram at the below in the lower side of this slide, light is passed through the sample solution directly, and the amount of scattered radiation is measured generally at the 90-degree generally at the 90-degree angle. And the measurement of the intensity of the scattered light as a function of concentration of the dispersed phase is the basis of the analysis. In turbidimeter, what happens is we measure the amount of transmitted light and calculating the absorbed light by the particles in suspension to determine the concentration of the substance. Now, the amount of absorbed light is it depends upon the number of particles, contaminants present in that particular sample, and also the size of the particles. So these pictures will clarify this particular phenomena further. You see, this is the incident light. Now, depending upon the particles or the impurity present in the sample, some of the light will be absorbed and it will be scattered. So, if the more number of particles are there or impurity is there, more will be the scattering and lesser will be the transmission of light. So when we measure the transmission, that is direct, this light, you can say it is moving, some of the light directly we measure in front of it. That is known as turbidimeter detector or turbidimeter, and this is all the instrumentation diagram is given in the lower part of this slide. So we have a light source, and we allow this light to pass to the sample, and then at the receiving end in the through photocell detector, we find out what is the amount of light which we receive after this light passes through the sample. So there will be difference in the two light intensities because there are certain particles which are present in the solution, thereby causing the absorption or other phenomena of the light. In the scattering, we always measure at some angle with respect to the straight line when we want to understand the phenomena with respect to nephelometry process. Here we generally measure at 90 degrees, that type, this, or it may be depending upon the type of the element, the angle might be little bit lesser than the 90 degree. Now, a very important instrument which is used for finding out the characteristic of the certain pollutant, that the main that is known as spectrophotometry. Now, what is a spectrophotometry or spectroscopy is also a similar term. What happens is, in this type of property, when we measure, it is basically the study of the interaction between the matter and electromagnetic radiation. Spectroscopy and spectrography, it refers to the measurement of radiation intensity as a function of wavelength. So please try to understand this very important concept. Spectral measurement devices, they generally are referred to spectrometers, spectrophotometers, spectrographs, or spectroanalyzers. We should understand what is electromagnetic radiation, right? Because this is the basic of understanding what happens to the light when when we want to analyze it. Now, light is what? There is a different frequencies and different wavelength. There is a special light waveform, and this light, it travels at the speed of light, right? And visible light is one small part of whole electromagnetic spectrum of radiation. We have X-rays, we have ultraviolet rays, infrared rays, microwaves, and radio waves. They are also the part of electromagnetic radiation, and light is also form of the energy. Now, this electromagnetic radiation, it is of dual nature. It is having the wave as well as particle nature, which you might have read in your when you were studying the physics. Then it requires no supporting media, electromagnetic radiation. While when we want to measure the sound, if we see, it requires the supporting media, but light doesn't. So it travels with the speed of light, and the wavelength is one of the important parameter which is related with the electromagnetic radiation, through which we can gauge what type of what is this particular spectrum which is there for a particular type of light, or with particular type of this radiation which we are going to study. So wavelength is the distance from the peak of one wave to the peak of the next. Another parameter which is associated with the electromagnetic radiation is the frequency. It is measured in the generally hertz. It counts the number of waves that passes by a point in 1 second. Now, wavelength always correlates with the energy. Like, for example, the color of the star tells us how hot it is. Red stars are the coolest, but blue are the hottest, right? Now, we have various ranges of various type of radiation in the spectrum, like this, not depending upon the type of wavelength. Like that is the amount of wavelength. The visible region, it lies from 400 to 750 angstrom. Ultraviolet, it is around 400 angstrom, and infrared light is 800 angstrom. So this shows, the picture shows the waves of electromagnetic radiation, where you can see that electric field and magnetic field is associated with the radiation, and they are perpendicular to each other. And the wavelength, as you can see, it is from one peak to another peak. This is the distance, and amplitude is how high it is, and it always with respect to the direction of propagation. Now, electromagnetic spectrum is a collective term for all known frequencies and their wavelengths of the known photons, right? So each part of radiation is associated with certain photons or energy. These waves are typically described in the form of three physical properties. One is frequency, another is wavelength, and third is the photon energy. Now you see the spectrum where you can see that as the wavelength increases, the frequencies decreases, right? So they are opposite, they are inversely proportional to each other. Generally, you can see we know that infrared radiation, it lies from 0.75 to 100 microns. Microwave radiation, it lies from 0.1 millimeter to 100 centimeter. This is the wavelength. Radio frequency lies from 1 to 1000 meter. Gamma from 0.02 to 1 angstrom. X-rays is from 1 to 10 angstrom, and ultraviolet lies from the region from 10 to 400 nanometers. Now, if you want to see the size of the wavelength of different type of radiations, then it is apparent from this diagram. To say the radio frequencies, they are having a lower wavelengths, right? That is 10 raised to power 3, and the size of this wavelength is about the building. Then microwave, it is 10 raised to power minus 2. Sorry, it should be, it is of the size of human beings, the wavelength. The infrared, it is 10 raised to power minus 5. The size you can just compare with the honeybee. Visible is 0.5 to 10 raised to power minus 6. It is of the order of pinpoint. Then ultraviolet, it is having a lesser wavelength, 10 raised to power minus 8. X-rays, then it is having a 10 raised to power minus 10 is the wavelength, and gamma rays is 10 minus 12, that is equivalent to atomic nuclei, very small, the wavelength. However, the frequency is the opposite. For example, the radio frequency is having a very high wavelength, that is 10 raised to power 4 hertz. Sorry, it is a lower side of the frequency, 10 raised to power 4 hertz, while the gamma rays is having the highest wavelength, it is 10 raised to power 20 hertz. And in the lower this side, you can see the temperature of the bodies emitting the wavelengths with respect to their wavelength or frequency. More you can see, right? So, and when we see the visible spectrum, there are, it is, as you might be knowing about this, there are 7 colors. Like violet color, it has a specific wavelength that is from 380 to 435 in nanometers. In blue color, it is having a wavelength of 436 to 480 nanometers, and greenish blue is 481 to 490, and so on. And red is having the 651 to 780 wavelength nanometers. It is having the highest wavelength, red color, while the violet is having the lowest wavelength. And if you see the these electromagnetic spectrum, the various radiations are used for different purposes. You see, if we see beyond the visible region, right, on the ultraviolet side, these radiations are ionizing radiation, and they are generally used for diagnostic purposes, radiation, and they are also used for therapeutic radiation, right? When we go from the lower side, that is from the red side, if you see, we have infrared radiation, then we have microwaves. Microwaves generally range from 3 to 30 gigahertz. Then we have the certain frequency of these spectrum, which is used for our mobile phone signals. So that range from 1.9 to 2.2 gigahertz. And then we our Wi-Fi, here the frequency range lies from 2.4 to 2.5 gigahertz and 5 to 5.8 gigahertz. And the remote control, the frequency which is used is 5.8 gigahertz. For TV broadcast, the waves which are used, this range lies from 54 to 700 megahertz in frequency. And radio, then AM is 520 to 1610 kilohertz, while for FM the range of the waves which are used is 87.5 to 108 megahertz. And for computer, 60 to 800 megahertz are used, and power lines 50 to 60 hertz are used, as which we are familiar with. Now you see, when we see the wavelength, then it shows that, you see, if the high energy is related with the lower wavelength, as you see in this diagram, the gamma rays, which is having a 0.1 nanometer as a wavelength, it is having the higher energy. Whereas when we move ahead of such wavelength of these radiation, then you will see that when we go towards the radio and TV waves, which is of the order of 25 centimeter the wavelength, it is associated with the lower energy level as compared to the gamma rays. And if you see the frequency wise, then high frequency is associated with the you can see and with the high energy, right? So high frequency is there, and the following is the comparison between the ultraviolet, visible, and infrared radiation with the for energy, frequency, and wavelength. Ultraviolet radiation is having higher energy than visible region. Visible region is having higher energy than infrared, and similar, and it follows the same pattern in frequency. Ultraviolet is also having a higher frequency range as compared to visible region, and visible range is also having a having higher frequency as compared to infrared. But it is opposite when we talk about their wavelengths. So if we now, depending upon the frequency of these various type of radiation, special transitions takes place. When these type of electromagnetic spectrum, they strike certain particles, right, of any substance, certain changes in that particular particle or that particular substance takes place at the atomic level or molecular level, depending upon the type of the substance and type of measurement which we want to take. For example, you see, if in the gamma rays, the transformation which takes place, the transitions which takes place when it strikes a substance is up to nuclear level. When X-rays, it passes through certain substance, then it changes the core level electrons. When ultraviolet strikes the particular substance, it changes the valence electron's position. When visible range it strikes, it also changes the valence electron position in a particular substance. In infrared, molecular vibrations takes place. In microwave, molecular rotations and electron spin changes takes place. And when the electromagnetic spectrum of radio waves, it strikes up or interacts with substance, then in that substance, nuclear spin changes takes place. Right? So we can see that depending upon the type of radiation, for example, if it is a gamma rays, their frequency range varies from 10 raised to the power 20 to 10 raised to the power 24 hertz, and wavelength will be lesser because they are oppositely inversely proportional. Then the transition within the particular element is up to nuclear level. In X-rays, which are having the frequencies from 10 raised to the power 17 to 10 raised to the power 20, here the inner electron changes with respect to its position. In ultraviolet rays, where 10 raised to the power 15 and 10 raised to the power 17 is the frequency range, the outer electron, there the transition takes place. Visible also similar transition takes place. Near infrared range, we have the outer electron and molecular vibration. These changes takes place in a particular element. In microwaves, we have a molecular rotation and electron spin flip. So spectroscopy is also known as electronic spectroscopy. It involves transitions of electrons within a molecules or ion from a lower to higher electronic energy level, or vice versa, by absorption. It means whenever it absorbs energy, the electron, it will move to the higher shell. Or emission. If it is based on the emission type of spectroscopy, then it will emit certain radiation which is falling in the UV or visible region. So visible range is 400 to 800 nanometers. Near UV, ultraviolet is 200 to 400 nanometers, and far ultraviolet is 150 to 200 nanometers. So depending upon which type of transition we want to analyze, it depends upon the type of substance or type of material which we want to look upon as and find out the pollutant and its quantity. Right? So spectroscopy is method to measure how much chemical substance absorbs light by measuring the intensity of light as a beam of light passes through the sample solution. The working principle is that each compound absorbs or transmits light over a certain range of wavelength, and this measurement can also be used to measure the amount of known chemical substance. So this quantitative analysis in various fields can be used, such as in the field of chemistry, physics, biochemistry, materials, chemicals, engineering, and for clinical applications. So whatever the instrumentation techniques which we are going to know about with regard to spectroscopy or other phenomena, it is not limited to only in the environmental field. The application is also in the other field, maybe in the field of medical or engineering or chemical. So spectrophotometer is an instrument that measures the amount of photons, that is the intensity of light absorbed after it passes through a sample solution. Amount of a known chemical substance can also be determined by measuring the intensity of light directed, and depending upon the range of wavelength of the light source can be classified into two types. Spectrophotometry, जो भी हम उसको phenomena को study करते हैं, it can only detect those elements where the electron change in the electron position takes place, and these type of electrons only which we can study is of the two type which can change their position when they interact with ultraviolet region or visible spectrum region or with the infrared region. So depending on which type of light intensity we are using, we generally have two types of spectrophotometers. One is UV and visible, and another is IR spectrophotometry, right? Because they uses the light ranging from in that particular spectrum, right? So this diagram will help you to understand it in a better way. See, in any element, it is consists of a nucleus and electrons which revolves around it in the particular shells. Whenever the energy or photon, that is a part of electromagnetic radiation, it passes they interact with each other, then what happens, this particular electron, it absorbs that radiation, and because it has a higher energy level, so it will move to the next higher energy orbit, right? So what will happen when it will move up, then it will absorb certain energy. So what happens, the spectrum, the lines on the spectrum which can be seen on the other side, it changes. So when it absorbs, suppose this is the continuous spectrum, then these black lines will occur. You see, there is some devoid of certain wavelength of line. It means this particular type of element is present there. So through spectrophotometry, there are two analyses. One is qualitative, another is quantitative. As I've discussed earlier, that certain that wavelengths like violet color is associated with certain wavelength. If that particular part of color is missing in the spectrum, it means that particular element is present there. And how much light it is absorbing, it depends upon the thickness of these lines, black lines, you can see in the diagrams. Now, atomic absorption spectroscopy and atomic emission spectroscopy, it involves visible and ultraviolet light. These absorptions and emissions, they often refer to as atomic spectral lines, which you have seen earlier, and they are due to electronic transitions of outer shell electrons as they rise and fall from one electron orbit to another. See, atoms also have distinct X-ray spectra that are attributable to the excitation of inner shell electrons to the excited stage. Each atom is having different spectrum, right? Different, like we have, every human being is having different biometric. Similarly, these atoms, every atom is having a different spectra, electromagnetic cell spectra. So thereby we can find out which type of element is present in our sample. Like even biometric and even eye scan. You see, every human being is having different this scan also, right? So we can identify the person by our biometric indicators. Similarly, they have the different fingerprints, we can say in a simple language, by way of which we can identify which type of element is present in the solution. So atoms of different elements have distinct spectra, and therefore atomic spectroscopy allows for the identification and quantitation of the sample's elemental composition. So it can be used for qualitative analysis as well as quantitative analysis, both. This is one of the example. For example, there is an atomic emissions transition. Now what happens is, whenever any electron, it absorbs energy and it moves to the higher orbit, it goes for some time only, right? For nanoseconds only. It is there on the higher transition level. To come to a stable position, it just comes down to the previous position, his stable position. When it comes down again, it emits certain radiation. Now the amount of radiation which is emitted by the electron, which is when it moves from higher level to lower level, is equal to the amount of energy or photons which it absorbs while it moves from the lower level to higher level, right? So based on this principle, our spectroscopy or photometer methods are based. Like this is one of the example. This is Balmer series transition for a particular element. Now, depending upon which scientists have carried out the research in particular area, the name of the series have been given. This is one of the example. Like where in this particular element, when from shell number 2 or orbit 2, and there is an orbit 3. So when electron from orbit 3 it comes down to the orbit 2, then the wavelength which is emitted by this particular electron is of the photon is of the wavelength is 656 nanometer, and it is of red color. So we can identify which type of this radiation or photon is present and which type of element is there. When it falls from 4th orbit to 2nd orbit, then it will generate different type of energy, right? That is of course much higher. Similarly, when we go to shell number 6, it will fall down to shell number 2, then 410 nanometer. That is lesser wavelength but more frequency, right? And different color of the light will be emitted. हाँ पार्टिकल इज सेम बिकॉज डिपेंडिंग अगर सपोज उसको इनपुट एनर्जी ज्यादा मिलेगी तो सेकंड सेल से 6th सेल में भी जंप कर सकते हैं, राइट? तो अगर 6th सेल से नीचे जाएगा तो पता लग जाएगा दिस पर्टिकुलर टाइप ऑफ एनर्जी फोटोन ही हैज टेकन, right? So these are two phenomena which are based on the similar principle. One is atomic absorption spectroscopy, where and one is atomic emission spectroscopy. Right now, here what happens is, as you can see, there is a light source. One thing in difference between AAS or AES, I'm just using the short word, is that here the light source is there, and this light source should be equivalent to the type of element which is going to be analyzed in our sample solution. Because that particular element, the atom of that element will be only excited when same photon or same type of energy is given to that particular element. Right? Suppose we want to know about what is happening in the lead, then same type of light should be given to this particular sample, so that electron, it will jump to the higher orbit, and thereby what happens is, as you can see here, the electrons are jumping to a higher orbit by absorbing certain radiation, and thereby the spectral at the detector which can be seen is this type. Certain black lines are appearing, something is missing. So which thing is missing? That wavelength is associated with the particular type of element. So we can analyze which type of element is there and how much is the width. That will determine type of intensity. How much is the quantity of that particular element or that atom is there in the sample. In atomic emission spectroscopy, there is no light source. There is only heat source. Now what happens is, when heat is given intense, and then it will move to, it will be unexcited, then it will move to excited level, it will come back to its stable form. The electron will come back to its stable form. This heat is just to atomize जो हमारा मटेरियल है, सैंपल है, उसको हम एक्साइट तभी करेंगे अगर वो एटॉमिक फॉर्म में होगा ना, तो उसको एटॉमिक फॉर्म में कन्वर्ट करने के लिए वी गिव द हीट एनर्जी, एंड देन इट बिकॉज द एटम्स दे आर इन द एक्साइटेड स्टेट, दे विल कम डाउन, right? And which type of energy do they give? It depends upon the type of wavelength. So you will have only this spectral line, only particular color you can see, right? And the thickness of this spectral line will tell you which type of material is there. So in atomic absorption spectroscopy, it is a procedure for quantitative determination of chemical elements using the absorption of optical radiation by free atoms in the gaseous state. This is very important, that first we have to convert our sample into gaseous state and into atomic form. It is used for determining the concentration of a particular element in a sample to be analyzed. AAS can be used to determine over 70 different types of elements in a solution or directly in the solid samples, which is used in pharmacology, biophysics, and other type of research. So these the table which is shown here, it shows the element which are highlighted in the pink color. These are the elements which can be detected by atomic absorption spectroscopy. So just see the number of elements there, like lithium, magnesium, sodium, iron, cadmium, and so on. Lead is also there, and so many elements can be detected by this phenomenon. So here the electrons in an atomizer can be promoted to the higher orbitals for a short period of time, just few nanosecond, by absorbing the defined quantity of the energy of a given wavelength, and this amount of energy is specific to a particular electron transition in a particular element. Each wavelength corresponds to only one element, and the width of absorption line is of the order of a few picometers only, which gives the techniques its element selectivity. The radiation flux without the sample and with the sample in the atomizer is measured using a detector, and the ratio between these values is converted to analyte concentration using Beer-Lambert's law. So this is the Beer-Lambert's law, which states that absorbance of a solution is directly proportional to the concentration of the absorbing species of the solution, that is what is the element present in that, and also the concentration of that, and also the path line, what is the area through which it moves. Now this shows the instrumentation of this. There is a light source, there is a lens, there is a monochromator, and here is a prism which converts the light into several wavelengths, and we can select the wavelength depending upon the type of element which we want to analyze. So that through wavelength selector, so this light passes through the solution, excites the electrons, and thereby we can detect through the photocell on the display meter, and that which is calibrated and which can directly give us the quantity of the light absorbed. So this is explained in this diagram. Then what are the various parts of the spectrophotometer? First, we have a hollow cathode lamp. This is the lamp which emits the light of a specific wavelength to be absorbed by the element. And then there is an atomizer. You see, there is a particular flame you can see, and it is of a flat flame having a higher, you can say, area. It is not a narrow flame. It is an atomizer. It atomizes the sample to the atomic state, and atom, vapor, gas phase are produced. Here you can see these are the other part where there is a fuel is there which is burnt. Here what happens is, oh, usme, ma'am, that has to be changed. So we what slide, because participant need to see the slide. Only then they literally understood. That problem at our side. Prism is a different thing. But grating is a different thing. But they are a part of monochromator. Their single wavelength is allowed to pass. Single. Very interesting phenomena also. And we know basically physics is involved, no? Although it is chemistry type of element, but physics involved. हाँ जी, हाँ अभी भी है. Right. So I'll continue. See, there is a source of light which should have the same wavelength as the element which you want to measure. Then this special we have a mixture as well as a sample which is dehydrated and atomized through this particular component of our instrument, and then it is passed through the burner, and it is excited, it is to the atomized in the atomic state, and then this atomic emission, then through the slit we allow certain wavelength only to pass, and then what happens is now whatever depending upon the type of the sample, then through photodetector we can detect the output, the spectrum of this, and which is, although the curve is there, then it can give directly the amount of the concentration of the particular element, or this graph calibration. There is a special graph I'll show you. Then that is given as the output depending upon what type of output do you want. So generally what happens, initially we require the our sample in a liquid sample into atomic gas to be converted. Then it involves a process of desolvation. Here the liquid sample is evaporated and dry sample is remained. Then vaporization is the solid sample, it vaporizes to a gas, and volatilization is the compounds making up the sample, they are broken into the free atoms. The spectrometer, it produces a desired range of wavelength at first. First, a collimator or lens, it transmits the straight beam of light, photons, that passes through a monochromatic chromator prism to split into several component of wavelengths, that is spectrum, and then a wavelength selector slit, it transmits only the desired wavelength. Then photometer, what happens is, after the desired range of wavelength of light passes through the solution of a sample in a cuvette. Cuvette is a tube, and generally it is made up of glass. It should be inert. It should not react with any element which is present there. And the photometer detects the amount of photons that is absorbed and then sends the signals to the digital display. So this type of spectrum is available. It is basically, it can be seen. So what does it shows? That these at this particular wavelength, this is absorbed. Here after 300, say 320 or 30, and then this is the wavelength which has been absorbed. Now what happens is it indicates that, say it is 320 and 300 nanometers is the element which is having 320 nanometer of wavelength is the element which is present in our sample, right? So if there are three lines, spectral layers, so depending upon the wavelength, three types of elements are present in our solution. So this indicates the qualitative analysis. Now, what is how to know about the quantity of these particular elements present? So they are associated with the area which is under this curve. So if you see, higher is the peak, bigger is the peak, so larger quantity of that particular element is present in our sample. So, and now how to do, how it is gauged? It is through the calibration curve. Now, what is actually being done in the calibration to determine the unknown concentration of the element in a solution? The instrument is calibrated using several solutions of the known concentrations. The absorbance of each known solution is measured, and then the calibration curve of a concentration versus absorbance is plotted. The sample solution is fed into the instrument, and the absorbance of the element in this solution is measured. The unknown concentration of the element is calculated from the calibration curve, which will be clear when I'll show you these graphs. So this shows that from the standard solution, this is formed. This is of the nickel, like magnesium per liter. This is the concentration, and this is the absorbance on the y-axis. Right, on the x-axis is the concentration of a known type of this, and this is the calibration curve. Now we want to know about the unknown solution, the new solution which we have put there. So the curve will automatically, it will tell us based on the absorbance, because that is which will be indicated by the instrument now, and the concentration which will be displayed will be of, say, in this particular case, it is 3.5 gram per liter of a particular type of element which we are measuring, right? So this is how the output is given, and this is the calibration curves are used for each type of element. Right? And now here, where these atomic absorption spectroscopy is applied, it is used for clinical analysis like blood sample, whole blood, plasma, serum, calcium, magnesium, lithium, sodium, potassium, iron. It is also used for environmental analysis like monitoring of our environment, finding out the levels of various elements in rivers, sea waters, drinking water, air and petrol, like 70 elements are there. So which type of elements are there? In mining also it has its application to determine the amount of metals such as gold in rocks, which can be determined to see whether it is worth mining the rocks to extract the gold. Now this is what is the, again, some problem is there. So here you see these are the again I'm going to explain about the atomic emission spectroscopy. You see each element has its own spectral lines. This is the wavelength. These are the absorption lines. As you can see, like hydrogen, it is towards the red side. Sodium is towards the yellow side. Calcium, you can see towards the purple and pink side, and so on. Right? So these are specified, and this, just see the animation in this, then you will understand both absorption and emission phenomena. How does it actually occurs? Now, if you I'll just tell you that, see, these are the radiation which is going through the element. Now, what is happening is when it is moving, this electron is going to higher orbit, then it releases the energy. Just see these radiations are falling on a particular element, and they're interacting with the electron. Now this electron has moved to the higher orbit, and thereby on the right side absorption line spectrum, you can see where something is missing, right? Because that photons have been absorbed. Now what is happening in emission, right? Now let us see in the next coming up animation. Here the radiation is moving towards this, and the atom is excited to the higher level. Now when it is moving to the lower level, you see it emits certain radiation. That is the amount of radiation it has absorbed, and based on that, this emission type of lines are formed. You can see there is only single line that for that particular this. You just have a look once again. These radiation are moving. So when it is say emission, through emission, this particular you can say particular light is emitted, and that is the emission spectrum. So what happens is that this is the continuous spectrum where no interference is there, right? But when it absorbs certain energy, then this is the spectrum which we get, and thereby we can analyze the element. And when it releases the energy in emission type of spectroscopy, then this is the emission spectrum which we can see on the spectral lines, right? So these is the difference. So depending upon the type of element, we have to employ either absorption or emission type of spectrophotometry. So this is the emission spectrophotometry. No light source is there, but this is the absorption spectroscopy where hollow cathode lamp is employed. Otherwise, other things are same. So flame photometry is also emission type of spectroscopy. This is atomic emission spectrometry. It is in here the inorganic elements are examined in the spectrometer, and they are in the form of atoms. Here the flame photometer, it is an instrument to determine the concentration of certain metal ions such as sodium, potassium, calcium and lithium. Flame photometry is based on the measurement of intensity of the light emitted when a metal is introduced into the flame. The wavelength of color tells us what is the type of element, that is the qualitative analysis. Ma'am, ये फिर नहीं आगे हो रहा, and the Hanji? Okay. The color intensity tells us how much the element is present. ठीक है? जितना ज़्यादा intensity होगी, उससे पता लगेगा how much the color is present. Now the flame photometry, generally group 1 and group 2 metals, they are sensitive to flame photometry because of their lower excitation energies. The species of the alkali group metals, group 1, and alkaline earth metals, group 2, they are dissociated due to the thermal energy provided by the flame source. And due to this thermal excitation, some of the atoms are excited to the higher levels when they are not stable. The movement of the excited atoms to the lower energy level with the emission of some radiation, which can be visualized in the visible region of the spectrum. And these radiation emitted from the flames, it depends upon the characteristic element present in the flame. And we need to calibrate the device before going in for flame photometry. So here, this liquid sample containing the metal salt solution is introduced into the flame. The solvent is first vaporized, leaving particles of solid salt, which is then vaporized into gaseous state. The gaseous molecules, they are dissociated to give neutral atoms which can be excited by thermal energy of flame. The unexcited, unstable and excited atom, they emit the photons when they return to the lower or stable energy state. And these are measured, the emitted photons, which forms the basic of flame photometry. So this is the spectral lines. You can see different colors of the spectral lines like hydrogen. Then this is the helium, second one. This is for neon. And these spectral line of the sodium, and this is for mercury. This one is for mercury, right? So this is the process explained that we do the aspiration, that is vaporization in flame. The molecules, they are dissociated in the flame, and then the higher energy is absorbed by the electrons. And when they move towards the stable, from the excited to stable form, that energy is emitted, and when they return to the ground state, and this energy is measured. So this slide shows the wavelength of the emitted light with respect to specific element. Like lithium, the wavelength is 670 and color is red. For sodium, when it is excited, the color shown is yellow. For potassium, it is violet, and for calcium, it is orange, and so on. So this shows a schematic representation of the flame photometer. We have a flame which gives the excitation, and then it is we have a monochromator, and then there is a photodetector which detects the amount and type of the light, which spectrum which comes from the after the process. Here, the important part is that fuel and oxidants. They are very much important because they convert the neutral the sample into neutral atoms, and which get excited by the heat energy. So the temperature of the flame should be stable and ideal. If the temperature is high, the elements in the sample is converted into ions instead of the neutral atoms, and if it is low, then atom may not go to the excited state. So it is a combination of fuel and oxidant is used so that we attain the desired temperature. So this shows that we use which type of fuel and which type of oxidant, and what type of temperature is required to be maintained in the flame. For example, propane and air, if we use, then 2100 degrees Celsius is the flame temperature. And similarly, if we use hydrogen in air, then 1900 degrees Celsius is the temperature. So high temperature from 2000 and 3000 degrees Celsius are there when we use the flame photometry phenomena. Now, the application of these flame emission photometry is to estimate sodium, potassium, calcium, lithium, etc. in the sample of serum, urine, and other body fluids. It is useful for determination of alkali and alkaline earth metals. It is also used for determination of lead in the petrol, and it is used in the study of equilibrium constants involving ion exchange resins. It is used in determination of calcium and magnesium in the cement, and also for determination of concentration of calcium in hard water. So this was regarding the one of the very significant working principle of instruments which are used for analysis of pollutant in water and air. Although there are other variety of instruments also, but this is widely being used, and most of the analysis of various type of, as you can see, elements can be performed through atomic absorption spectroscopy, atomic emission spectroscopy, through nephelometer and turbometer. So thank you so much. So we are going to have a question answer session. So we'll move to good afternoon.
Good afternoon, ma'am. Good afternoon, ma'am.
Yes, please. From which center? The question
This is regarding the atomic absorption and atomic emission spectroscopy.
Hanji.
Ma'am, what
Yes.
is the basic difference between these two techniques?
It has been explained just now. No, I'll explain it to you again. I'll just show you the slide which is explaining this. अभी दिखाते हैं. We are just going to. I am showing you the slide, and just Monica ma'am is just going to connect us accordingly, so it will so that it is clear to you.
Okay.
From which center the question is being asked? May I know, because Bharatiya Vidyapeeth.
From Bharatiya Vidyapeeth College of Engineering.
Okay. See, suppose there is no sample and we have electromagnetic radiation. Okay. So this type of spectrum can be seen, right? But suppose there is a sample and it has got certain pollutant in it, and we are going to go in for atomic absorption spectroscopy. So what will happen? This type of line spectral will come. You can see some black lines are coming in the spectrum, right? So this type of phenomenon can be seen. It means some of the light part is absorbed when our electromagnetic spectrum or light spectrum is passed through that particular sample, and the light, the range or the wavelength or the color of the light which has been absorbed, it is associated with the type of element which is being analyzed, right? As I have shown you the slide, like for sodium it is yellow color. For that particular wavelength, if that line is missing, it means sodium is there present in the element. And the thickness of these lines, right? How much width is of these lines, it shows the amount or concentration of a particular element, that particular element present in the sample. Right? And when we talk about the emission spectrum, so this type of phenomena can be seen when we go in for flame photometry. So what happens is, we can see the photons which are released when they are excited. That is, they absorb certain amount of heat energy. Inorganic compounds or organic, the type of compounds which we are going to measure, they will absorb certain energy depending upon the energy level of a particular element of certain atom, and then they will go to from excited state, it will come back to the ground level or the stable type of orbit, the electron. When it will come back, it will produce that particular type of color, or that wavelength will be emitted, as you can see the spectrum, and the width of these lines will show you the intensity of that particular element which is present. And if you see this animation, you will understand the basic phenomena of these two particular type of spectroscopy. but you have to be attentive to understand it. See there, if you will see here number of, there is a spectrum light or radiation which are going to be passed in an element. Now when these light, it strikes the electron, what happens is the electron, it goes to the higher orbit. When it goes to the higher orbit, since it is this is excited state, it wants to go to the stable state, so it will emit certain light which is in the form of emission spectrum. But in the absorption, what happens? It will It will absorb. It will move to higher state, and thereby certain radiation will be missing. When this radiation will go to the other side, then that is known as absorption phenomena, or it is basis of absorption line spectrum or absorption spectroscopy. Is it
Right,
okay?
ma'am.
Okay. Any other question?
Yeah, ma'am. One more question, ma'am.
Anji,
Can we use, ma'am, laser light source for these two techniques?
कौन सा source?
Laser light source, ma'am.
See, I have told you, it depends upon the type of element. If the laser light is having the wavelength which matches with the wavelength or photon which is required to excite the electron for that particular element, then it can be taken into account. I have told you, no, I have shown you this, that special type of depending upon the type of element, that is type of element, the light source can be passed. You can see this slide.
Yeah.
For example, in this slide, you see that I told you, depending upon the type of element and the amount of energy it requires to excite this electron, that particular wavelength of light source is required to excite. So whatever is the wavelength of the laser light, so depending if it is matching with the energy required to excite the electron, that particular element can only be detected by using the laser light. I am not aware about the wavelength. That is why I cannot precisely answer your question, but it is for your information. Okay.
Okay, ma'am. Ma'am, these pink colors elements are atomic absorption spectroscopy elements, and other white elements are?
No, that is not. That is different. Not white elements are not covered here. It is only atomic absorption. It is just a table which I have been shown to make you aware. But this is not connected with that particular question which you are asking. I cannot tell randomly about the white elements. I can just say that 70 elements can be detected through absorption spectrophotometry, and inorganic elements, they can be detected through the flame photometry, like sodium potassium. Okay.
Okay, ma'am. Okay, thank you, ma'am.
Any other question from your center?
Hello.
Yes.
Hello. Good morning, ma'am. I am Dr. Sheetal from Krishna Institute of Engineering Technology. Ma'am, I had one question. When we are taking the spectras, so some reference material is required for calibrating them, or we can directly take run the spectra for the materials?
No, you see, calibration is always required whenever you be going for measuring any element. It is always advised to calibrate the instrument, so it needs to be calibrated. Like I've shown you the curve, no, calibration curve. So that automatically is formed within the, and processing is done within the instrument, but calibration is required.
Okay, thanks a lot, ma'am. Voice.
Any other question? So we'll move to next center. Firozpur. Yes, please. Any question from your center? Yes, please. Any question from your center?
No question.
Okay. We'll move to University of Engineering and Management, Jaipur.
No question, ma'am. Thank you.
Okay. MBSIT, Sonipat. Yes, please. I don't think we have any questions. Any question from our participants? Ghaziabad, we have covered. No? We have covered all the centers. From our side, any questions? From वेदर में तो डिफरेंट होता है ना एस्पेक्ट. इट इज में टेम्परेचर होगा, प्रेशर होगा, ह्यूमिडिटी होगी, वो इससे नहीं है. हाँ, इट इज नॉट रिलेटेड विद दिस, है ना. दैट इज द डिफरेंट फिनोमिना. वो आपकी क्लासिकल मेथड या दूसरे मेथड को डिफरेंट मेथड से करेंगे ना. प्रेशर के लिए अलग होता है टेम्परेचर, हाइग्रोमीटर एंड ऑल दिस. बट फॉर पोल्यूशन दिस टाइप ऑफ instrumentation is used. So I would like to thank all the participants for your patient hearing. And now we are going to start the valediction of this short-term course. So I'll request all the nodal centers to kindly be connected with us, and so that we can take the feedback from you regarding this short-term course. And I would request that if any chief guest is there to speak on this occasion, so then it is requested that they also might provide their inputs during this session. So we can start the valediction of this short-term training program. So we will start from Bharati Vidyapeeth, College of Engineering, New Delhi. We would like to know about your experience with regard to participate in this course. Yes, please.
Hello, ma'am. Myself, Dr. Anil Kumar, local center coordinator from Bharati Vidyapeeth College of Engineering.
Yes, sir.
Ma'am, we have registered 30 candidates from our institute and approximate 5 to 10 candidates from other institutes, ma'am.
Okay.
Total, we have 30 candidates. Ma'am, total sessions was very excellent. And in previous 4 days, we have number of participants and they benefited from your PPTs and other, but some problems are also there, ma'am, due to interruption in the voice and other technical problems.
Okay. We can understand some of the problems are not in your hands, like connectivity and other, but
yeah, due to technical problem in internet from our side or also from your side, ma'am.
But otherwise, I think most of the parts of the sessions you might have been able to attend, because I have seen during all the sessions that the participants from your center were very active and they used to ask the questions. So it means that most of the time the transmission was there and you could understand what was being discussed from our side.
And our suggestion is also, ma'am, could you explain some practical experiment on these techniques, ma'am? If our participant want to came there in NITR Chandigarh, can they did your research work, ma'am, in these fields? If you have some research facility.
Yes. We have the instruments like spectrophotometer, flame photometer, and other instruments related to the environment. And you are most welcome to come here, and you can just try to find out which type of facilities do you require. And to which for your research work, right? And you are most welcome to attend the courses here also, because there are generally 2 type of courses we coordinate here. One is through ICT mode, like we are conducting that now this particular course, and one is contact mode, where you can come to our institute and then you can see our laboratories, and even we demonstrate the working of the various instruments in such type of courses. But here there is a limitation, because it's very difficult to bring the equipment here and then demonstrate it. Not feasible because of the technical reason. So we have to skip. We cannot show that particular thing. But you are most welcome to attend our courses here, and you can get to know the facilities to carry out the research.
Okay, ma'am. Ma'am, one more suggestion from our central participants. The suggestion is about the refreshment and tea from NITR side, ma'am.
Okay. Yours is a private institute?
Actually, ma'am, NITR not provide any facility regarding refreshment or tea, ma'am.
Okay, I understand. Actually, these norms are from. We have to. You can say, see what are the norms which have been provided by our institute, and especially since we are funded by Ministry of Human Resource Development. So whatever the directions come from the higher side and from the finance, we have to go according to it. So I'm really, I I feel sorry that this type of financial provision is not provided to the private institutes.
Ma'am, but from candidates participating from government institutes, you will provide refreshment, TED, etc. But not for private candidates, ma'am. It's a partiality, ma'am.
This is not a partiality. These are the government of. We are working at the Ministry of Human Resource Development. So they have whatever the instructions we get from the finance side. Accordingly, we have to implement.
Ma'am, इंडिया में 1200 कानून बदल चुके हैं, तो मैम ये भी कानून बदल सकता है.
इसके लिए तो we can just take up this thing to higher authorities. I can just do that. But the implementation level, again, it depends upon the grants and instructions from the higher side. So we'll try that.
We will write a letter. We will write a letter to Director NITR for this purpose, ma'am?
Okay, you can write the request to the director of our institute that if it can be sorted out, then I hope it can be sorted out. But I cannot commit on anybody's behalf, no. Anyone's behalf.
Okay, ma'am. Your cooperation is very nice, ma'am, for this FDP, ma'am.
Thank you so much, and thanks for active participation from your center. Thank you so
much. Ma'am, kindly please interact with the one participant, sir.
Yes, please. Any other person who want to speak?
Hello, ma'am.
Speak loud.
Anji. Hello.
Good afternoon, ma'am.
Good afternoon.
Hello, I have a question.
Anji.
What is the best suitable method to drag the consideration of heavy metal ions consideration from spectroscopy?
Will you speak little slowly because we cannot understand your question?
Okay. What is the best suitable method to detect the concentration of heavy metal ions at lower concentration by spectroscopy?
That I have already explained. It is atomic absorption spectroscopy, jahan lead, everything you could see, they have been used to determine lead and other metals, 70 type of metals and other elements. Right?
Say for ma'am, I have a concentration of N/10 for chromium metal. So, which method we can use?
I have already shown you the table. Please listen to me. I have already shown you the table. Which type of compounds can be detected by the atomic absorption? You have to refer to that to understand, to know about which type of element can be detected through which type of phenomena. There are 70 type of metals that now I don't have.
Okay.
So you have to see that, and accordingly you can employ that particular method.
Thank you, ma'am.
Any other question?
Yeah, ma'am. One more question from other participants.
Hello. Good afternoon, ma'am. Hello.
Hello.
Good afternoon. Overall, the things went very well, except of course some limitation might. Suppose we want to use the facilities available there. Now, what is the? Have we to write the letter, an application to you, or directly bring this?
आपकी आवाज ना कट रही है, एक बार प्लीज रिपीट कर देंगे क्वेश्चन? आपकी आवाज पूरी हमें सुनाई नहीं थी, कट.
I'm asking.
हाँ जी.
Suppose I want to do some testing done at your place.
हाँ जी.
I suppose to take prior permission, or can I take the samples and visit there and it will get it done?
No, you have to contact the head of the department who is having that particular instrument, like our environmental engineering laboratory comes under civil engineering department. You have to talk to the person concerned, faculty concerned, so that the lab facilities are available. Because you see, it is not only that we are conducting experiments there, certain consultancy projects are also being carried out by our institute. So that whenever you come in here and your work is not hindered and you can get the at the convenience of both of you, at your side and our side need to be coordinated. So you have to write to the concerned faculty, and so that you can fix up your time for carrying out the experimental work.
So it's on chargeable basis?
That I think there are some charges, but you have to contact the faculty in charge of that particular lab. He will.
Okay. There also there is discrimination between government institute and private institute.
No, it is not like that. The rates are same.
Okay. Thank you.
Any other observation or? Okay, then we'll move to next set. Guide Ghaziabad.
Hello.
Hello.
Yeah, good afternoon, ma'am.
Good afternoon.
I'm Siddharth Jain, local coordinator of from Kite Group of Institutions. Hello.
Yes, we are listening to you.
Hello.
Yes, we can listen to you. We are hearing you. Please continue.
Okay, ma'am. We have 12 participants in total, one from other college and 11 from Kite Group of Institutions.
Anji.
The general feedback is like, ma'am, first of all, some improvement should be there for the solving of the technical issues, like in between sound is not clear, or like your PPT which you are giving, ma'am, like other speakers are giving. They are also not so much of a good quality, like for blurred images there. So we should have done something like to improve that technical part so that it can be more fruitful.
As given the feedback by our technical people here, from Monica ji and Mishra ji, they are looking at from the technical part of connectivity. Actually, our bandwidth is quite good at our center, but maybe there is some issue with respect to connectivity bandwidth at your center. So maybe you can try to upgrade it next time so that the sound and the visuals, they are clear at your side. Okay, you have to take it little efforts you have to put in for upgradation of your connectivity.
Okay, ma'am. And next, ma'am, this PPTs and all the matter, can you give us for the participants so that we can have a look and use it?
Okay, you can. Okay, I'll. If you can through email, I'll try to send. If it so much content is there, if it will. At the YouTube also it is available. All lectures are available in YouTube. That is the best part. From till now. Okay, that is easily accessible to you. You can access that. And please tell us about the course. Which lectures did you like and why, and what new things you have.
Sure.
Yes, please. Would like to hear from your side.
Hello.
Yes.
Hello.
Yes.
Good morning, ma'am. Ma'am, we are very, very thankful for such an informative lectures which we had received. But the only problem is that at the time of question hours, the quality and the interruptions are there. So therefore, we are not really getting the voice properly. So that is the only problem. And second thing is we want to connect with your institute and we want some research work to be carried out further. So what kind of a help can we get from your center?
Okay, for that you have, I think it is better if you visit our institute so that you come to know what type of facilities are there. So depending upon the type of facility, you can
so ma'am, we have to coordinate with whom over there?
You have to come and see first our laboratories. You have to see whether your research work which you want to carry out that is available here. If it is available here, you have to contact the faculty or head of the department of that particular department, and then
Okay, ma'am. Thank you.
Any other? So we will move to next center, SBSSTC Firozpur. Yes, please.
Good afternoon, ma'am.
Good afternoon.
On behalf of our college, SBSSTC Firozpur, sincere thanks to Ma'am Poonam and the other team members who have conducted this course and give us the opportunity for conducting the same in our department. All the sessions that were conducted, they were very informative and they were with the line of the today's need. And special mention to the session given by Ma'am Dr. Geeta Arora, on the topic of aspects and issues of genetically modified crops with respect to sustainable development. That the session was related to the health, so all our participants like the course, like the session very much, and thanks, ma'am.
Thank you so much. Any other person from your side would like to speak?
I would like to thank Madam Poonam Sayal for designing such a informative, the short-term course. It was very well designed, very well delivered, and I must congratulate you, Madam. It was very much enlightening. And vis-a-vis, I would like to thank our director and the local coordinator, Madam Anupam Mittal, and the co-coordinator, Madam Navneet Kaur, and here Madam Maninder also. And Madam, really this, and I would really like to give my vote of thanks to Bunia ji also, usually for designing this ITC-based education. And ma'am, really these kind of courses should be really part and parcel of this kind of education, because it was very much informative, although we have all this knowledge, but at time, like the one course which that Madam Anupam was talking, we got to know that the genes of fish, all those people are saying that we are vegetarian, but we are taking all these kind of genes of fish in our diet using tomatoes. So I mean, ma'am, really it was really informative, and we need to work to collaborate, and we need to do some work in future together. Thank you so much, madam. Thank you so much.
Thank you so much for your encouraging words, and it really motivates us further to upgrade our inputs and towards the coordination of courses. Thanks for your encouraging words.
Good afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am. I am architect Sandeep Singh, assistant professor in the Department of School of Architecture. I have done my master's in sustainable architecture. It was quite learning experience about energy efficiency, environment, sustainable development, or innovative ideas to conserve water or rational use of resources, and designing the building envelope to provide proper window wall ratios or fenestration design to provide thermal comfort to the human, or new ECBC 2017 in Punjab proposed, and about the daylighting design. The knowledge given in these lectures will be very helpful in our teaching. And ma'am, in last, we are very thankful for this course conducted by NITER Chandigarh and Department of Electrical Engineering SBS Firozpur, to ma'am Anupam ma'am, and we will hope to have more lecture session in coming years. Thank you, ma'am.
Thank you so much. Thanks for your observations and positive feedback. And thank you. Anybody else from your side? Thanks to the participants, and we are really glad that there was a good participation in all the sessions from SPSS TC Firozpur during this short-term course. So thank you so much for your coordination and for sponsorship of your faculty for this training program. Thank you. Now we'll move to University of Engineering and Management, Jaipur.
Hello.
Yes. Hello.
Very good afternoon, ma'am.
Good afternoon.
I'm Sukanya, Dr. Sukanya Das, and actually I am also teaching a few of the courses this semester, and the content you have discussed, it was really enlightening for all of us, and I'm very highly motivated to incorporate some of it into my lecture as well. Thank you very much for your initiatives and the supporting lectures. Thank you.
Thank you, ma'am. Thank you so much for your encouraging words. Anybody else from your center would like to speak? Yes, please. Anybody else?
No, thank you, ma'am.
Okay, thank you so much. And thanks for your active participation from your center also during this short-term course. So next we move to MBSIT Sonipat. One person, very few. The participation from this center was really discouraging, although I remarked in between also, but that is something to be looked into. So now we'll move to our institute. The participants from here to kindly provide your feedback. If you can kindly come here, and because Mike is here about the course, please provide your feedback. I'll request some of the participants.
Myself, Narendra Kumar, Senior Lecturer from DN Polytechnic Meerut. पूनम सयाल मैडम ने जो ये कोर्स STC हमारे लिए रखा, काफ़ी जानकारियां मिली इससे हमें, काफ़ी कुछ। अब जैसे मैं लेक्चर लेता हूँ अपने पॉलिटेक्निक में, तो बच्चों को जो भी मैंने यहाँ से गेन किया है उससे अवेयर करूँगा, और ज़रूर इस चीज़ से जो है बच्चों को भी कुछ ना कुछ फ़ायदा हो। और मैडम से एक ही रिक्वेस्ट है कि आगे जो है और कोर्सेज, शॉर्ट टर्म कोर्सेज करें, ताकि हम जो है ज़्यादा से ज़्यादा अपना पार्टिसिपेशन उन कोर्सेज में कर सकें। थैंक यू।
Thank you so much. Yes, please. Introduction.
My name is Bhavin Kanani, working as an assistant professor in Darshan Institute of Engineering and Technology, Rajkot, Gujarat. As we are working on energy and environment field in through the consultancy as well as some research projects in industry. Before I came, I have, मतलब मुझे एक expectation थी, I have expected much more to learn regarding especially from environment. And जैसे ही प्रोग्राम शुरू हुआ और डे बाय डे नए नए टॉपिक्स ऐसे आ रहे थे, जैसे सिविल इंजीनियरिंग के बेस पे थे, फिर हमने वो जेनेटिकली मॉडिफाइड फूड्स का देखा, तो कुछ ऐसे एरियाज थे जो हमने अभी तक अनटच रहे थे, स्पेशली फ्रॉम एनवायरनमेंट साइड। सो कुछ ऐसे यहाँ आके हमने नॉट जस्ट वी गेट सर्टिफिकेट, बट वी एक्सप्लोर सम other areas that we up till now did not explore. And I assure to madam that next time we will be the part of this STC program as a nodal center. I request to my institute head to get this type of nodal center, which will providing much better information at our institute also. क्योंकि गुजरात से मुझे यहाँ पर आना पड़ा ये सीखने के लिए, तो बेटर है कि ये सेंटर अगर वहाँ पर हमारे इंस्टीट्यूट में आ जाए तो वहां से ही हम काफी कुछ बैठे बैठे ही सीख सके। और ये भी आई थैंकफुल टू पूनम मैडम एंड NIT TTR, as well as I am specially thankful to MHRD and Government of India to provide this like facilities and courses. And यहाँ पर जो मुझे फैसिलिटी मिली है, चाहे वो लॉजिंग बोर्डिंग की हो, all facilities are very excellent provided by NIT TTR. So again, I thankful to Poonam madam and its team. Thank you.
Thank you so much.
A very good afternoon to all. Myself, Rajkot, Assistant Professor, Lovely Profession University. Since the day we have come here, starting from the hospitality and the cordial environment which was provided by the department and all the team involved in this short-term course, Dr. Poonam ma'am and the other fraternity of the department, all have been very helpful. The cordial behavior was much touching. And then coming to the content of the short-term course, it was not focusing only one aspect of the system, of one aspect of society, but all the key aspects of the society which we need to have knowledge of, and we should focus on all those aspects being of any discipline. So each of the key areas which we as individuals should work upon were discussed, and which will be very helpful in our future, and we can very easily guide our students. Plus, yes, we will be looking forward for various such courses in future. Thank you so much.
Good afternoon to all. Myself Anurag Agarwal from Moradabad. Basically, I am an electrical engineer, and the topic of this course was related to energy, environment, and sustainable development. Ma'am, really thankful for giving me permission for this course, because first time we are interacted with these topics. As an engineer, it is expected from us that we should have a little idea about what is happening around us regarding energy, regarding something, what is pollution or what is that. So apart from the electrical field, first time we are interacted that there is so much to be concentrated on, and if we are aware, then we can also incorporate in us, in another contribute also. Like smart grid wala, it was our field, and ma'am instrumentation wala, it was great actually. Yeah, last lecture, because we are from instrumentation background. So ma'am, for example, there's a soil erosion, the Dr. V.K. Bhatt, ma'am, thorough knowledge and very explanative way of taking lecture. So we can come to know that there is a जो मेड़े होती हैं उसके भी पीछे एक technical reason है. जो बीच में वो लाइनें बन जाती हैं, जो रोड में बीच में जो cracks होते हैं, they all are scientific things. But main thing is that we are aware of it, that it is technically there. रोड कट जाती है हमारे संग में और हम उसको. But why it is happening and what can we do for the corrective action?
What can be done for them?
Ma'am, for the first day to last, there are many different things, aspects, and all are making the different interesting things. We enjoy a lot. Actually, ma'am, what happened when we consider on a single topic, na, after 3 days, it's feel that we are stressing something. But saturation level comes. But here, there is a new things always, new exposure and new things. Craze was there. Man. Only one lecture I missed due to some
without feeling well.
Yes, sir. But I was missing there. I should be there on that day. So, but it was great. So, I'm really thankful. Ma'am has allowed us to. And ma'am, food is really excellent. Okay. And my weight is continuously increasing, and it is observed by Bhag Singh ji of electrical department that you will be फट जाओगे तुम अपना इतना खाते रहेगा. So thank you very much, and thank you all. Thank you, ma'am.
Thank you so much. So I am really glad that as with regard to the feedback which has been conveyed by various participants at different centers at our main center, it has really encouraged me, and I am thankful to you for coming here, especially from the other states also, and attending this program. So on behalf of Electrical Engineering Department and of our institute, and especially from myself, I would first of all to thank all participants of this short-term course from at our center as well as at the different 5 centers who have, and I would like to thank their management and the local coordinators for putting in their efforts and coordinating the programs at the nodal center at their end, and for sponsoring the participants for this short-term course. And I'm grateful for their participation, active participation at most of the centers were there. Only 1 or 2 centers we have found that the lack of interest was there. But although I requested them in between also that kindly ensure the participation, but there was still some limitations maybe from their side. But in future, I hope that these will be overcome and more active participation will be there from the centers which have been lagging it. Anyway, I thank them also, and thank all the participants, their local coordinators, their management at the nodal centers, and for sponsoring and sparing their time and learning the new things from our short-term course. I would especially like to thank the participants who have come from far and to come to our institute and be here with us for the 5 days and listening to the various topics, and also showing the interest, because the reaction from the participants who are sitting here is much more apparent as compared to at the nodal center, because it is the connectivity and other issues related, and sometimes we cannot gauge your expressions. From here we get instant feedback when a person is teaching something, and when we see that the interest is being shown by from the participants, then it motivates the speaker and to share the experiences and in a more energetic way. And thanks so much to all of you once again, and also for your positive remarks for this short-term course. And we hope that we will all be again meeting again for other short-term courses of similar type in future too. I would like to thank the ETV department for their coordination, for their support which have been given, especially by two of my colleagues, Mishra ji and Monica ji, who were always with us for the 5 days and taken care of all the technical aspects. Thank you so much. And I would like to thank the computer science department also, because they see the Hangout and all connectivity this type of area, technical area. So thanks for their support. I would like to thank our electrical engineering department faculty and my other colleagues who have contributed directly in the form of lecture, like Dr. Lini Matthew. She took the lecture on smart grid for sustainable power system, and also Dr. Ritla was there in the inauguration and in between the session. I am really thankful to all my faculty colleagues for their contribution. I would like to thank our other colleagues also, and all the other departments who have been directly or indirectly associated with this short-term course. So thanks to one and all. Thank you so much, and hope we will all meet